Hello, hello, hello. Hi everyone, how are you all? Having fun? All good? Math board exam is going. How long would it take to start? I'm so sorry, Bhavya. There was one more educator in the room, so it took a while. I think I am late. Apologies for that. So, am I audible? Please confirm first. Bhavya, am I audible and visible? All good? All good? Audible, visible, audible, visible? Or do I have to check? Good evening. Thank you. Okay, so today we have our exam on 8th of March, right? 8th of March. This is our exam date. So from today we are starting. Okay, see, in boards, I'm sure that you must be preparing for your competitive examinations, but this is a bit different. Not more difficult, it's easier, but this is a bit different. Here in these sessions, which is going to start from today and will be there till 7th, in these sessions, I'm going to tell you how to write answers, what to do if you don't know an answer. Suppose sometimes, yeah, this condition or this situation will also write that you might not know the answer of a question. Then what to do? How to attempt that? That should also be known, no? These smart techniques you should know so that you are able to score 95 plus at least. Okay, this is important because as I told you, class 12th is a lifetime statement and in maths you, if you can get good marks for the lifetime, you can tell that I'm good at math. Even after, like suppose you get bad marks and you get better at math afterwards, that statement cannot be made. If you go for jobs, if you go for scholarships, if you go abroad for anything, there they'll first thing they'll ask for is your 10th and 12th mark sheet. Trust me, I have faced that. Although my marks in 10th and 12th in maths are good, but still I have faced that situation when they ask for your 12th mark sheet and they require good marks in your engineer. If you're going for engineering, then they require good marks in maths. They'll evaluate on the basis of that. That's for sure. Okay. Now, one thing before we start is about the batches, right? So there are 3 batches. If you have attended the RM session, then 3 batches are going to start. One is going to be the Nimbus batch for 11th class students, then Nexus batch for class 12 students, and Phoenix batch for the students who are going to uh, drop after 12th and they are going to give one another year for their preparation. So these are the batches. Duration, I'll try to keep it as, so I'll tell you, just wait for a minute, I'll tell you what will be the duration and everything, what all will be covered. So this is something, okay. So you can enroll in these batches. The link is there in the chat box right now. So if you want to enroll, you can enroll, and the fees is quite awesome. It's just 4,500, right, approximately, okay. So this code which is going to be there, this offer is going to be there till 9th of March. So if you are planning to enroll, if you have come to class 11th, if you are in class 12th, or if you are a dropper, then these 3 batches, this is an important information which I wanted to give before starting. Now let's come upon to our pattern. As we already know, there'll be 1 mark question, 2 mark question, 3, 4, 5 marks questions. So 1 to 5 mark questions we are going to have. Now in today's session, right, in today's session, there we totally have 6 units. So how I'm going to cover these 6 units, I'll explain you. Today we'll do relation functions and a small part which is ITF, inverse trigonometric functions. Okay, then algebra consists of matrices and determinants, matrix and determinants. So this will be covered in your algebra. This will do tomorrow. Then calculus means a lot of it. Calculus is a big chapter. So continuity, differentiability, right, applications of derivatives, integrals, standard integrals, definite and indefinite, both type of integrals. Then we are going to do applications of derivatives and application of intervals. So third day is going to be a quite hectic. It might go quite longer than the other days. I wasted last 3 days, but I want minimum 90%. It's okay, Sanjay. It's all right. That can be covered. Then on the 4th day, we'll be doing vector and 3D, which is very important. So as you can see, okay, I'll explain the marks. On the 5th day, we'll do these 2. On the 5th day, we'll do linear programming, which is small, and probability, which can be covered in a day. All right, so this can be your plan if you have not started anything so far, because obviously it's a long holiday. We wanted a bit of rest also, so you might not have started. All right, now first chapter, which is relation and function, consists of 8 marks. Number of periods you don't need to worry about. Many are there in syllabus, many are not there in syllabus. This consists of 8 marks. And how are these 8 marks bifurcated, or how are these 8 marks distributed? I'll tell you that, I'll explain you that. So generally 99% of the times 5 marks questions or 5 marks will be consisted of relation and function, right? 5 marks will consist of relation and function. 5 marks questions, not 5 mark question. I'm not saying 5 mark question. 5 marks will be asked or obtained from relation and function, and 3 marks generally are obtained from your ITF. Generally students think that these two are 4 marks because 8 marks is total. It's not like that. 5 marks will be obtained from relation and function, and 3 mark questions. 3 marks can be obtained from ITF. This is the segregation so far. Only once it has happened that they asked a case study from inverse trigonometric functions, which was of 5 marks. And that year, relation and function came for 3 marks only. Sir, what will be covered in today? Today, we are going to cover beta relation, function and ITF. Very small chapter, very small, very easy. This is, I'll tell you what all you need to cover, because no need to go beyond the syllabus. Trust me, there is no need. If you have old book, then don't do beyond 1.2. Only 1.1 and 1.2 you are supposed to do, not even miscellaneous. Because you can clearly see reflexive, symmetric, transitive, equivalence relations, 3 types of relations. Questions based on 3 types of relations can come, and questions based on 2 types of functions can come. No need to do composite function, inverse function and all those questions which are in your miscellaneous exercise. No need to do all that. Trust me. You can, because this is defined in CBSE website. They can, and CBSE does not go beyond syllabus. They cannot. They can be objectified. NTA does, because they can counter attack, but CBSE won't go beyond syllabus. So no need to do composite, FOG, GOF. These things are not even mentioned. Although FOG and GOF, because last year actually, there was one mark question which was asked on FOG and GOF. That I'll explain in the end, which is actually called composite function. F of GOF or GOF of F of X. Right, those type of things. In inverse trigonometry, very basic, only first exercise you need to complete. Right, questions won't come on basis of graphs. They might ask you something, they won't ask you to make the graph or anything, but still you should remember the graphs. Okay, questions will come from this part: definition of inverse function, range, domain, principal value, branch. Basically sine inverse 1 by root 2, or these type of questions they'll ask you, domain and range. That we are going to cover in today's lecture. Now, how are we going to cover? We'll cover all the types of questions that can be asked: 1 mark, 2 marks, which type of questions can be made, theory, what theory we need to cover, how we need to solve a question, or what all do we need to write in the question. So listen carefully. I'll give you some time to think on the question also, and then we'll proceed. So this is going to be the flow. Okay, today we are going to cover this much part, and the upcoming day schedule also I have told you. So shall we start? Okay. I believe that you should keep a notebook with you. It will be better. Okay. Keep solving the questions with me. Apart from this, now how are we preparing? Apart from this, what you need to do is go through the NCERT exemplar. See all the questions of NCERT exemplar, and by the end of the exam, what will be the duration? Better duration, I think it should be 2.5 hours. Right? Not more than that. Not even, we'll try to keep it crisp. If some doubts appear, then it might take more time, otherwise not. How you need to, after this, what you are supposed to do, you just need to go through NCERT exemplar, and on the end day, do some sample papers or not previous year papers. No need to do previous year papers. Okay, because syllabus is different. Do sample papers. Some of the sample papers you can do. NCERT, if you have time, keep solving along. Okay, so it's not going to take much long. Let's start. First thing is relation. What do we mean by a relation? What do we mean by a relation? Right, relation means you have studied in class A, right? Set A. Suppose we have 2 sets, set A and set B. Let's say your set A is 1, 2, 3. Okay, and set B is 4, 5 and or let's say, let me make something else. Let's say your set B is some 1, 4 and 9. Okay, so set A can be related to set B, or let's say there are more elements. Let's say 16 is also there, 25 is also there, 36 is also there. Let's say there are more elements. Okay. So set A and set B are two sets. Now what is the relation? If we take the elements of set A, let's say 1, 2, 3, okay, and elements in set B, which are 1, 4, 9, 25, 36, and yeah, okay, these many only. Now relation means any one element which is related. So 2 is related to 4, 3 is related to 9. Now 1, 2, 1, 2, sorry, 1, 1, right, 2, 4 and 3, 9 is a relation. Now you must have studied, right, A cross B. A cross B means Cartesian product of A cross B. That means all the relations will come here. All the relations 1, 1, 1, 2, 1, 4, 1, 9, 2, 1, 2, 4, 2, 9, 3, 25, 3, 36, 2, 36, 1, 36. So many relations will be there. Any relation which is subset of A cross B. Relation is a subset of A cross B. That's it. Relation is nothing but a subset of A cross B. Relation is a subset of A cross B where A and B are two sets. Any relation it can be. For example, over here, what is the relation? A square. What is your relation? Relation is defined like this: A square. Right? This is your relation. A square. 1 square, 2 square, 3 square. Now this is a subset. 1, 1, 2, 4, 3, 9 is a subset of A cross B. There are many relations in A cross B. But subset is this, a small part. A small part of it is called a relation. No need for question solving. We don't need to get into that much of detail also. What type of questions can be asked from this type? From the definition of relation. So far we have not entered the type of relation, but what type of questions that are asked. So in the questions which we have included, either they are previous year questions or sample paper questions or from NCERT examiner. Okay. JEE April attempt daily करो तो 3 subjects 1 on chapter daily करो क्या? I didn't get. Final revision start करूँगा. No, daily one chapter. It depends, beta. You have to how you are doing, right? Consume the time. Decide the time. Don't decide one chapter one day. Otherwise, time will be wasted. Decide like I'll be studying 14 hours or 16 hours every day. How much ever is covered in that I'll cover. That should be the way of studying. Okay. So now, what type of questions can be asked from this definition of relation? For example, this question: A cross B is given to you, right? A cross B is given to you. Find A and B, right? In options that can come. This type of question can come to you in the options also. They might give options. This is A, this is B. Or they might ask you in 2 marks that they can ask you find A and B. This type of question can come. So simply you can see A1 is there, A2 is there, A3 is there. Then B1 is there, B2 is there, B3 is there. So now this side, look at this side, AB, AB, AB. So your one set will be only of AB. First elements. Okay. Second set, 1, 3, 3, 1, 2, 2. So another set will be 1, 2 and 3. Then only A cross B will become A1, A2, A3, B1, B2, B3. All the relations in between A and B are included. That's why your set A and set B, your A is nothing but A and B, and your B set is nothing but 1, 2 and 3. Okay. Now one more thing here also, that left side of elements. Remember this. In relation also they can ask you range and domain. Remember, left or first, whatever you call, left side of elements are your domain and right side of elements are your range. Range and domain of relation can also be asked, not only for function. Range and domain of relation also can be asked. So this left side elements, that means what is the range? This is your, this is your domain and this is your range. range or codomain. Actually, you should call it codomain. Or but in case of relations, if they are asking you range, then this only. Range and codomain will be same in this case. All right. So this type of question they can ask. Now, what else? Relation. Let R be a relation which is a comma a cube, where, how to read this? Where a is a prime number less than 5, then find the range of R. This is a PYQ only. Okay. So this range of relation also they can ask you. Now simple. A cube. A is a prime number less than 5. What is the first prime number less than 5? 1. Is it 1? No, 1 is neither prime nor composite, right? So 1 is neither prime and nor composite. 1 is not a prime number, neither a composite number. So we'll start with 2. So 2 and 2 cube, that means 8 will be one element in this relation, right? Or relation R is equal to this relation. What else can come? 3 can come. 3 is also prime number less than 5. 3 and 9 can come. Can 5 come? No, 5 cannot come. Less than 5 they are saying. So now what is the range? Range is right side element. So range of R, simply we can say range of R is nothing but your 8 and 9. Oh, 27. 8 and 27. Sorry. Cube, right? So 27. 8 and 27 will become your range. So if they ask you range of a relation, then right side elements. Whatever your relation is giving, right side elements. In that, second elements, you can say. So this is your range. Domain, what is the domain? 2 and 3 is the domain of relation. Okay, range and domain of relation. This type of question can be asked. Some very related, something related to this. If range comes, then you should remember what you are supposed to do. Now, what they can ask you, one more thing which is based on class 11. In class 11, you must have studied that how many total relations can be formed. Based on that, also one question can be framed which they can ask you in definition of relation part only. Till now, types of relation did not come. Right? First part, what is the first topic in the syllabus? Relation. Then types, symmetric, transitive and your reflexive or equivalence. Now, here one more question can be made. How many total relations are there in A? To answer this very simple thing, total relations between A and B, set A and set B obviously, will be equal to 2 to the power of cardinality of set A. Cardinality means number of elements in set A. Cardinality, in class 11 we have studied. Cardinality means number of elements in set A multiplied with number of elements in set B. That's it. Okay, number of elements in set A and number of elements in set B. Suppose if I give you A is a set A is equal to 1, 2, 3 and 4, and set B is equal to, let's say, 3, 4, 5 and 6. Elements don't repeat in a set. Okay, remember that. If 2 4s are there, the number of elements will be 4 only. Suppose if there is one more 4, then your number of elements in set is still 4. Different elements, number of distinct elements you have to check. Okay, so what will be the total number of relations? Total relations over here between set A and set B will become equal to 2 to the power 4 into 4. That means 2 to the power of 16 will be total number of possible relations between set A and set B. How? Because total relations, set A can also be related to set A, right? If I want to relate set A, relation which I am defining from set A to set A, yeah, this is also a relation. All the elements of set A can be related to set A. That is also possible, right? So just remember, total relations will be 2 to the power of number of elements in one set multiplied with number of elements in another set. Okay. Now, one question which came on this part. Did we cover all the questions? 1, 2, 3. Yes. Okay. For definition, we didn't read. A relation R from set A to set B is subset of Cartesian product of A cross B obtained by describing relation between first element and second element of A and B. That we can clearly understand what is the definition. All right. So this was the question that was asked in previous years. I did not bring the years because questions repeat, you know, sometimes same type or same values or some different values, but the questions in CBSE boards do repeat. So this is one question which can come as objective, or even in 2 marks it can come, right? It can also be asked in 2 marks. Number of all relations on A. Now relations, my dear friends, are of two types: on the set or from the set. There can be two type of relations, right? So if relation is from A to A, that means relation is on the set. If relation is from A to some other set which is B, this is relation from the set. So here it is asking about relation on set A. That means it's asking about A to A, right? All the relations from A to A. Now how many elements do we have in A? N. How many elements here? N only. So what will be the total number of relations? 2 to the power number of elements in set A multiplied with number of elements in set A. That means 2 to the power of n multiplied with n. That means 2 to the power of n square. This was the correct answer. But many students made a mistake here. That year they marked 2 to the power n, which is not. It is asking relations on A. Okay. So this is how you're supposed to answer. This will be the correct answer. Right? A to B can be easy. That you can easily answer. Number of 2 to the power of number of elements in set A multiplied with number of elements in set B. That's how it is going to be. Let's move ahead. I hope till here everything is clear. Any doubt, anything which is confusing you, right? These type of questions you should know. In your NCERT also these type of questions are there. Exemplar also these type of questions are there, and these type of questions are asked previously also. Now we'll move to the next part, which is our types of relations. Types of relations. So there are certain types of relations. By definition, I'll explain you, and by example afterwards. Let's read the definitions first one. Or let's, yeah, okay. So first is empty set. Empty set means there is no ordered pair. There is nothing in the set. Empty relation means in this relation there is nothing. Right? Suppose we are doing A, relation of A to B, and we are saying that suppose this is your set A. Set A is let's say 1 and 2, right? And your set B is let's say 5 and 6, and you want to make a relation from set A to set B where element of set B is square of set A, right? Relation A to B, relation from A to B where A is A comma A square, suppose, right? So 1 comma 1 square, is it there? Can we make any relation? Is there any element in B which is square of A? No. So this will be an empty set, right? So sometimes they can ask you whether is this empty set or not. Check the empty set. So there is no relation, there is no ordered pair in your relation. If there is no ordered pair in your relation, that means your relation is an empty relation. Universal relation, that means a relation where every element of set A is related to every other element in set. Okay. Relation in which every element of set A is related to every other element in the set. Set A to set B. Suppose all the relations which are there, all the elements which are there in A cross B are there in your relation. In simple terms, all the relations which are possible in A and B, that means A cross B, all the elements of A cross B are there in your relation. That's it. For example, suppose your A is, okay, let me write here. Suppose your A is 1, 2 and 3 and your B is 5 and 6, and your relation from A to B consists of elements 1, 5, 1, 6, 2, 5, 2, 6, 3, 5 and 3, 6. All the elements are there. So your relation becomes a universal set. If all the elements of A cross B are there in your relation, in that case, it will become a universal set. although very rarely they can ask you a question because these definitions are mentioned in your book. That's why you need to know. Identity relation, that means every element is only related to itself, right? One same, every same, suppose if I'm relating A to A, that means every element is related to itself. In that case, it will be called an identity relation. Okay, identity relation done. Then basically most important over here is reflexive, symmetric and transitive and equivalence relation. Questions will come from these parts. We'll do L'Hopital rules, I definitely. Why not? Okay, we'll do L'Hopital rule. We'll do calculus on the third day. There I'll tell you how do we use L'Hopital rule. But in CBSE, you're not allowed to use L'Hopital rule. I'll tell you that. Don't use that in exams. Okay. Now, these type of relations. Abhi, let's do something. Let's say your set A has elements 1, 2, 3, 4 and set B has elements 1, 2, 3, 4, 5 and 6. Okay. Now, if your relation is from A to A, suppose if your relation has these elements 1, 1, 1, 2, 2, 2, 2, 3, let's say 3, 3, we have 3, 4, let's say, or only these elements are there in your relation. Now, according to the definition of your three type of relations, which are these. Okay, reflexive relation means, in simple words, these definitions are written over here. Reflexive relation means a relation where every element is related to itself. That means if in set A you have 1, 2, 3, then in your relation you should have 1, 1, 2, 2 and 3, 3. Every element is related to itself. Simple terms. Symmetric relation means if AB is there, then BA must also be there in your relation. Suppose in your relation you have 1, 2, then 2, 1 must also be there in the same relation. Then your relation will be symmetric. Then comes transitive. If AB is there and BC is there, then AC should also be there. If A and B is there, B and C is there, then A and C should also be there. If 1, 2 is there, 2, 3 is there, then 1, 3 should also be there in your relation. Now, for example, we wrote these elements. Now see, is this reflexive? 1, 1 is there, 2, 2 is there, 3, 3 is there. 4, 4 is not there in the relation. So, this is not reflexive. This is not reflexive. Symmetric, if 1, 1 is there, 1, 2 is there, then 2, 1 must also be there. So, this is not symmetric also. If 1, 2 is there and 2, 3 is there, then 1, 3 should also be there, which is not there. Simple way, in the simple terms, this is how you can check whether your relation is reflexive, symmetric or transitive. Okay, we'll understand this by the questions also, right? For now, this is how you must write it. But more importantly, suppose a question of question of reflexive, symmetric and transitive comes. How should you write mathematically? What should you write? Suppose if you are not able to prove also, even if you are able to write what is a reflexive, what is a symmetric and what is a transitive relation in mathematical terms, then also you will get partial marking. Okay, so suppose you are not able to prove a relation as reflexive, transitive and symmetric, at least write the definition. What do we mean by reflexive? How to write that the function is reflexive? How do we write if the function is reflexive? Okay, sir, okay, that I have read. Right, if A comma A belongs to your relation for every A belonging to main set, Am I audible now, guys? Hello, hello, hello. Hello. उससे कोई फर्क नहीं पड़ रहा मुझे. Jayasri says yes, I'm audible. Okay, great. Hello. Is the voice okay now? Is the voice okay now? All right. So let's move ahead. Sorry for the trouble. Reflexive relation we are calling, which is for suppose you are doing A to B. Your relation is from A to B, and for every element of A comma A is there in your relation. Suppose we are doing your A has the elements 1, 2, 3, and your B has some elements. Okay, let's say some elements are there. In your relation, you should have 1 comma 1, 2 comma 2, and 3 comma 3 should be there in your relation. These should be there. These are must. Rest, okay. Rest anything can be there. But 1 comma 1, 2 comma 2 and 3 comma 3 should be there in your relation. Then your relation becomes reflexive for sure. Okay. Now, suppose next thing is that symmetric relation. If A comma B is there, then B comma A should also be there. Then suppose you here you have 5, 6, 7, 8. And if your relation has these, also it has 1 comma 2, then 3 comma 5, and then 2 comma 1. 2 comma 1 is also there. 1 comma 2 is there, then 2 comma 1 is there. If there is, you don't need to check for others. Only check if the opposite of same ordered pair is present or not. If 1 3 is present, then 3 1 should also be present. If 2 5 is present, then 5 2 should also be present in your relation. Then your relation is even symmetric. Okay. Now transitive means if 1 2 is present and 2 2 is present, then 1 2 should also be present. Okay. If 1 2 is present, 2 2 is present, then 1 2 should also be present, which is not in this case. So this is how you are going to check reflexive, symmetric and transitive. Let's do some examples. And we'll understand how can we state or prove that a relation is reflexive, symmetric and transitive in any kind of relation or not. And simple thing, equivalence relation is a relation which is all the three, which is reflexive, symmetric as well as transitive. If all the three conditions are true, then your relation is nothing but equivalence relation. Okay, in that case your relation will be called as equivalence relation. Now let's see this question. For example, this is from the exemplars only, NCERT exemplars. Let L be the set of all lines in the plane. L is a set of all the lines which are present in the plane. L1, L2, L3, L4, L5. All the possible lines which are present in the plane are there in your set L. So set L consists of all the lines in plane. Right? R be the relation in L. Now R is a relation which is defined like this, where R is equal to L1, L2. R is a relation of L1 and L2, any two lines. right, between any two lines where L1 is perpendicular to L2. L1 is perpendicular to L2. This is how your relation is defined. And what is the set? Set is L. Relation is defined from set L to set L. Okay. Relation is defined on the set only. Okay. So now all the lines which are there in set L are the lines in the plane, and relation is that line L1 should be perpendicular to L2. This is the relation. Now, will this relation be transitive, symmetric, reflexive or not? In overall, we need to know that whether this relation is equivalence or not. Now, question is saying show that R is symmetric but neither reflexive nor transitive. Now, first condition, how will we write? How will we write? Right? How will we write? We'll write this relation first, right, which is L1, L2. This is how we'll write. Okay, where L1 is perpendicular to L2. This is your relation. Now, for all the lines, L1, L2, L3 and so on, for all the lines, this is, you can write in your own language also, but it should be explained. For all the lines L1, L2 and L3, relation L1, L1 will exist, yes or no? Relation this L1, L1 will exist or not? What do we mean by for, or first you can write for a relation to be, although you don't need to write, if it is a 2-mark question, you don't need to write, but it comes in 3 or 5 marks, then you need to write some stuff. For all lines in set A, or for all lines in set L, relation L1, L1 will be present. Every line will be perpendicular to itself. Yes or no? Will every line be perpendicular to itself? Because what is the relation? L1 is perpendicular to L2. Is every line perpendicular to itself? Can we say that? No. Is not possible or is not present because every line is not perpendicular to itself. Every line is parallel to itself. So this you can write because every line is not perpendicular to itself. So I'm telling you the best way. Whatever you understand, write it in the exam. That's what that is the deal. Because every line is not perpendicular to itself. You can write every line is not perpendicular to itself. So write like this. That's why this is not reflexive, right? Or you can write the definition of reflexive also. For a relation to be reflexive, A, should belong to your relation for every A in the set A. That means L1, L1 should belong to your relation for every line. But it is not possible because what is the relation? Relation is L1 is perpendicular to L2. Right? Suppose all the lines in set L is L1 and all the lines in set in the set L is of the L1, L2, L3, L4, L5, all the lines are there. But L1, L1 is not going to be present, right? Because for L1, L1 to be present, L1 should be perpendicular to L1 itself. Line is not perpendicular to itself. So it is not reflexive. So here after this you will write it's not reflexive. Now, transitive. How do we write for transitive? For R to be transitive, just write the definition of transitive. For R to be transitive, if A, B belongs to R, then B, A also belongs to R. For R to be transitive, if A, B belongs to R, then B, A should also belong to R. Now if L1, L2 belongs to R, suppose, then this means that L1 is perpendicular to L2. Then your L2, L1 will also be present in the relation or not? L2, L1 will also be present because as L2 will be perpendicular to L1. If two lines are perpendicular to each other, L1 is perpendicular to L2, then L2 will also be perpendicular to L1. Obviously, because this relation contains all the lines which are perpendicular to each other. Correct. So if L1 is perpendicular to L2, L2 will also be perpendicular to L1. A comma B belongs to R, then B comma A also belongs to R. So that means this is symmetric for sure, right? Now, if you need to write for transitive, right? For R to be transitive, just write the definition. For R to be transitive, if they want you to only prove transitive, right? For R to be transitive, if A comma B belongs to R and B comma C belongs to R, implies A comma C should also belong to R. That means if L1 is perpendicular to L2 and L2 is perpendicular to L3, hello, yeah, voice must be okay now. Now I'm saying, so here you can write, this implies, so here you can write if L1 is perpendicular to L2, don't write short forms, write complete words, and L2 is perpendicular to L3, then it is not necessary or it is not possible that L1 is also perpendicular to L3, right? It's not necessary that L1 is also perpendicular to L3. Suppose L1 is perpendicular to L2 and L2 is perpendicular to L3. Then it is not possible that L1 and L3 are perpendicular. In fact, it is possible that it is definite that L1 and L3 will be parallel to each other. They won't be perpendicular, right? So that means the condition for it being transitive is nullified. This is how you can simply write the definition and explain. So if L1 is perpendicular to L2 and L2 is perpendicular to L3, then L1 is not perpendicular to L3. That means if L1, L2 is there in the relation, L2, L3 is there in the relation, L1, L3 will not be there in the relation because L1, L3 will be parallel lines, not perpendicular. So that means simply we can say that this relation is symmetric because if two lines are perpendicular to each other, L1, L2 will be there, L2, L1 will also be there, but it is not reflexive and it is not even transitive. So this is how you are going to write. Let's see some more questions, some more examples. For example, this question, show that the relation R in the set 1, 2, 3 given by, this is the set, this is a set, some set A or set B, whatever you want to name you want to call it. Let's say call it set A. So 1, 2, 3 are the elements present in your set. And relation is in the set itself. That means A to A only, right? And relation is given like this: 1, 1, 2, 2, 3, 3, 1, 2, 2, 3. These are the elements in your relation. Now you have to prove or you have to tell that this relation is reflexive but neither symmetric nor transitive. Simply write the definition of reflexive, symmetric and transitive and show. What is the definition of your reflexive? Reflexive means that for all A belonging to A, your set A comma A belongs to the relation, right? A comma A should be there in the relation for all the elements of set A comma A should be there in the relation. 1, 2, 3 are present in your set A. For all of them, 1, 1, 2, 2 and 3, 3 should be present in your relation. Is it there? 1, 1 is there, 2, 2 is there, 3, 3 is there. So you simply write 1, 1, 2, 2 and 3, 3 belong to R. That's why it is reflexive. Okay. Symmetric. Now how will you show symmetric? For all A and B belonging to A, if A comma B belongs to the relation then B comma A also belongs to the relation. If 1 comma 2 is there, then 2 comma 1 should also be there, which is not the case. So you'll write like this: in R 1 comma 2 belongs to R, but 2 comma 1 does not belong to R. That's why it is not symmetric. Only for every element, 1 comma 1 is there, 2 comma 2 is there, 1 comma 2, for 1 comma 2, 2 comma 1 is not present. And you don't need to check. If even 1 is not present, then you don't need to check for others. Simply. Then this question is very important. Please pay attention how to check and how to write. So this is how: definition, then explanation, why it is not transitive, or why it is why it is not that type, or why it is that particular type. Now third thing is transitive. Now transitive, what is the definition? How do we write transitive? Transitive means for all A, B, C belonging to your set A, if A comma B belongs to the relation and B comma C belongs to the relation, then A comma C should also belong to your relation. This is how you'll write. Simply in these terms also you'll write, you'll get full marks. Don't worry about it. Okay. Should also belong to the relation. Now we'll check our relation. How will you check now? Now always check from second element. If you are checking for 1 comma 1, then check is there any element which is having first element as 1. This has second element as 1 and this has first element as 1. Now if 1 comma 1 is present and 1 comma 2 is present, right? 1 comma 1 is present, 1 comma 2 is present, then 1 comma 2 should also be present, which is the case. In this case, it's there because this is already reflexive, right? So 1 comma 1 is present, 1 comma 2 is present, 1 comma 2 is present. Okay. Now, any other relation which is starting from 1? No. 2 comma 2. 2 comma 2 is present. Second element is 2. Which element has first element as 2? Which of the ordered pair has first element as 2? This one. So 2 comma 2 is present, 2 comma 3 is also present, then 2 comma 3 should be present. Okay, no problem. 3 comma 3, any element which is starting from 1? No. Right? From 3? No. So you don't need to check for that. No need to check for that. If it is there, then only you need to check. Now check for this one, 1 comma 2. Any element which is any ordered pair which is starting from 2? Yes, this one. 1 comma 2 is present, 2 comma 3 is present, but 1 comma 3 is not present. So you'll simply write like this: in R, 1 comma 2 belongs to R and 2 comma 3 belongs to R, but 1 comma 3 does not belong to R. That's why it is not transitive relation. Simply just check like this. Okay, suppose your R had these type of relations. Your R was somewhat equal to 1, 2, 2, 3, 1, 3, 3, 4, and 2, 4. Suppose these are the elements. Now this is definitely not your reflexive. Okay, 1, 2 is there, 2, 1 is not there, so this is not symmetric also. Now check for transitive. 1, 2 is there, 2, 3 is there, 1, 3 is also there. Okay, this second and this first. 2, 3, any element which is starting from 3, yeah, any ordered pair which is starting from 3, 3, 4. 2, 3 is there, 3, 4 is there, then 2, 4 should also be there, which is also there. 1, 3, but still we are not complete. 1, 3 is there, 3, 4 is there, but 1, 4 is not there. Now they can ask you to make this a transitive relation, what should be added? So you'll have to say you need to add 1, 4. If you add 1, 4 over here, if you add just 1, 4, 1 and 4 over here, 1, 4 also has ordered pair, then this relation is your transitive relation also for everyone. For all of these, 1, 3, 3, 4, 1, 4 is there, 3, 4. Now for 3, 4, is there any ordered pair which is starting from 4? No. So you don't need to check for that. It's still transitive. If any ordered pair was starting from 4 and corresponding to that, transitive relation was not there, then only you need to check. In this case, you don't. Now this is completely transitive. 1 2 is there, 2 3 is there, for that 1 3 is there. Okay, 2 3 is there, 3 4 is there, for that 2 4 is there. 1 3 is there, 3 4 is that there, for that 1 4 is also there. 3 2 4 for 4, from 4 there is nothing starting, so you don't need to check any further. This is completely transitive now. This is how you are supposed to check in any of the questions that you get. Shall we move ahead? Okay. In the relation R, set 1, 2, 3, 4, 5 defined as A, comma B. This is also a PYQ or a sample paper question, right? Very easily you can say, now come on, check. You only check. You tell me, is this reflexive? Can we call it reflexive? These are the elements of set A. Now for R to be reflexive, you'll simply write for R to be reflexive. A comma A should belong to R for all A belonging to set A. This is the definition. That means 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4 and 5 comma 5 should be present. But is it possible? Because what is your relation? Relation between A and B is B is equal to A plus 1. And we cannot write 1 is equal to 1 plus 1. 1 is not equal to 1 plus 1. You can write for 1 comma 1, 1 is not equal to 1 plus 1, right? This relation cannot be defined. Can you define this relation on 1? Can you define this relation on 2, 3, 4 or 5? Any of these? No. That's why this is not reflexive, right? And it is not possible for, or you can write like this also. A is not equal to A plus 1 for all A belonging to A. That is why this is not reflexive. Or in MCQ, if they are asking, that, they can ask you the same type of questions in different scenarios. That's another case. But this is how you are supposed to solve it. Okay, let's look at this. Yeah, this is also one question which is from NCERT Exemplar, and also this has appeared multiple times in CBSE boards. What is the question saying? For set A, which has elements 1, 2 and 3, define a relation R in the set A as follows. This is the relation in set A to set A only. This is the relation in set A. Relation is 1, 1, 2, 2, 3, 3, 4, 1, 3. Now, what are they asking for? Write the ordered pairs to be added to make it the smallest equivalence relation. For equivalence, what do we need? Reflexive, transitive and symmetric, or reflexive, symmetric and transitive. Now, for just write the definition. Okay, now you know how to write, so I'm not including that part. For all the elements of set A comma A should be present in the relation. That means 1 comma 1, 2 comma 2, 3 comma 3 should be present in the relation. That means it is definitely reflexive. Present, so definitely reflexive. Now, for symmetric, if 1 comma 3 is there, then 3 comma 1 should also be there, which is not present. So we'll have to add 3 comma 1, right? For transitive, do we need to check anything for transitive? Here we don't need to check anything for transitive. See, 1 comma 1 is there. Any element which is starting from 1, only this. 1 comma 1, 1 comma 3 and so 1 comma 3 should be present. 1 comma 3 is already there. Okay. Any other element which is starting from 2? No. Any element which is starting from 3? No. So this is already transitive. Only to make it symmetric, we need to just add 3 comma 1. Right? We just need to add 3 comma 1 to make it equivalence, because this is symmetric. As soon as we add 3 comma 1 over here, right? 1 comma 3, 3 comma 1, 1 comma 1 is already present, right? 1 comma 3, 3 comma 1, then 1 comma 1 is already present. So this is transitive also when we add 3 comma 1, right? It's not breaking the transitive condition. This is already reflexive, and now we have made it symmetric also, because if 1 comma 3 is there, 3 comma 1 should be there, so it will become symmetric also. So symmetric also. Transitive also we have made. Any element which is starting from the second element is connected True. If A comma B is there and B comma C is there, then A comma C is also there in the relation. 1 comma 3 is there, 3 comma 1 is there, then 1 comma 1 is also there, right? So nothing else we need to check for making it transitive. So smallest element that we are supposed to add, or smallest equivalence relation if we are supposed to make over here, we just need to add 3 comma 1. That's it. It can be asked in MCQ or in a subjective question of 3 marks or 2 marks. Explain. They can ask you to explain, or they can give you options. This can be asked. So smallest element, this is how you are supposed to check. Okay. Let's do some more questions. Which all right now we have come to objective types. These are all objective types of questions. Just a minute, guys. ये वो इसलिए रहा है वो तो सही से आवाज नहीं आ रही है Okay, so this question, sorry for the sound issue, some issue came for sound, that's why I had to call for help. All right, now this type of objective question can also come where they can simply ask you whether this relation is symmetric, transitive or equivalence or not. Now, for example, this is the question, let R be the relation in the set is 1, 2, 3, 4, the set is of 4 elements 1, 2, 3, 4 and the relation is 1, 2, 2, 2, 1, 1, 4, 4, 1, 3, 3, 3 and 3, 2. Now we need to choose the correct answer. Okay, let's okay, right. So for it being reflexive, if it is reflexive, then for all the elements 1, 1, 1 should be there, for 2, 2, 2 should be there, for 3, 3, 3 should be there, and for 4, 4, 4 should be there. So 1, 1, 2, 2, 3, 3 and 4, 4 is present. Okay, symmetric, so this is definitely reflexive. Okay, now for symmetric, if 1, 2 is there in the relation, then 2, 1 should also be there in the relation. Is 2, 1 present? Is 2, 1 present? No. Similarly, if 1, 3 is there, then 3, 1 should also be there in the relation, which is not the case. If 3, 2 is there, then 2, 3 should also be there. So definitely this is not symmetric. Now transitive. If 1, 2 is there, 2, 2 is there, 1, 2 should also be there. Okay. If 2, 2 is there, and which element is starting from 2? No element is starting from 2, right? No other element is starting from 2. No need to check. For 1, 1, any element which is starting from 1, 1, 2. For 1, 1, 1, 2, 1, 2 is present. 1, 2 is already present. For 4, 4, no element is starting from 4. No need to check. For 1, 3, which element is starting from 3? 3, 3. So 1, 3 is there, 3, 3 is there, 1, 3 should also be present, which is the case. No problem. Now for 3, 3. And again 1, 3, 3, 2. For 1, 3, 3, 2 is also there. 1, 3, here is also 3, here is also 3. For 1, 3, 3, 2, 1, 2 should be there, which is the case, which is present. For 3, 3 and 3, 2, for 3, 3 and 3, 2, 3, 2 should be there, which is present. 3, 3 and 3, 2, 3, 2 is present. Not a problem. 3, 2 is already there. Anything else which we are missing? For 1, 1, 1, 2, 2, 2, 1, 2 is there, 1, 2, no other element is starting from 3. We have checked for all the conditions of transitive, so this is transitive. So function is reflexive and transitive, but not symmetric. This function is reflexive as well as transitive, but not symmetric. So for transitive, you have to check very carefully, right? For 1, 2, check last element and check all the ordered pairs which are starting from 2. So this is starting from 2. So for 1, 2, 2, 2, 1, 2 should be present, which is there, right? For 2, 2, which element is starting from 2? No. For 1, 1, we checked. This is how you are supposed to check, right? Second element of first one and first element of second one. That's how you are supposed to check. So this is transitive, this is reflexive, but this is not symmetric at all. Okay, so these type of questions, 1 mark question can be asked. This is also a NCERT exemplar and a question from sample papers. Let L be the set of all lines in plane, XY plane, and R be the relation in L, from L to L only, defined as L1 comma L2, where L1 is parallel to L2. Show that R is an equivalence relation. We can show easily. What is, we know all the three definitions. Now how will we write? For, simply for R to be reflexive, for R to be reflexive, write the condition for R to be reflexive, which you know. For all A comma A belonging to, A comma A should belong to R for all A belonging to the set, or for all A belonging to L. Here the main set is L. So yes, this is true. This is true. Now R is reflexive. We can say R is reflexive because L1 and L2 will belong to L, as all L1 and L2 will belong to L, as a line is parallel to itself. A line is parallel to itself. Yes, every line is parallel to itself. Every line is parallel to itself. So that means yes, it will be reflexive. Now second thing, for R to be symmetric, for R to be symmetric, what do we say? If A comma B belongs to R, then B comma A should also belong to R. A comma B belongs to R implies B comma A belongs to R, or comma, with comma also you can write without any problem, will also belong to R. Here instead of R you should write L, because main set is, no, R only, here R only, here R only. Yes, what am I doing? Okay, and we can say if, what happened? If L1 L2 belongs to R, implies L1 is parallel to L2, and L2 then L1 will also belong to R, as L2 is parallel to L1. Obviously, if two lines are parallel, they'll be parallel to each other. That means it is, so here you have to write hence it is reflexive, and here you have to write hence R is symmetric also. Hence your R is symmetric. Now third thing, for R to be transitive, write the condition, right? If A comma B belongs to R, B comma C belongs to R, then A comma C should also belong to R. That you have to write. And you can see, if L1 L2 belongs to R, implies that L1 is parallel to L2, then L2 L3 belongs to R, that means L2 is parallel to L3. This also implies that L1 will be parallel to L3. Obviously, if one line is parallel to another and this line is parallel to one another line, all the three lines will be parallel to each other mutually, right? That you can write and then write. That's why R is transitive also, right? If L1 is L, you even after writing the definition of transitive, even if you write in the simple words that if L1 is parallel to L2 and L2 is parallel to L3, then L1 will also be parallel to L3 for all the lines in the planes, all the lines in the set L. This will be true for all the lines in the set L. That means the relation is also symmetric. The relation is also transitive. And if the relation is symmetric, reflexive and transitive, in that case relation is called equivalence. That means this relation is definitely equivalence. Find the set of all lines related to y is equal to 2x plus 4. So this you can simply write y is equal to 2x plus c for all c belonging to R. For all c belonging to R. Yes, all the lines with the same slope will be parallel to this line. So find the set of all the lines. This is, you can write like this: set of all the lines, write in the set form, right? Set A where y is equal to 2x plus c and c is belonging to any real number. This c can be any real number. right? All these lines with the slope 2 will be parallel to this line. So this is how you are supposed to write. This type of question can be asked. Let's see this question. Now I think you'll be able to do, show that relation R is defined for all triangles T1, T2. T1 is similar to T2. Relation says, relation between T1, T2 is that T1 is similar to T2. Relation between two triangles where T1 is similar to T2 is a equivalence relation. You can show, right? First, a triangle will be similar to itself. So it is definitely reflexive. If T1 is similar to T2, then T2 will be similar to T1. That means it is symmetric. If T1 is similar to T2 and T2 is similar to T3, then definitely T1 will be similar to T3. That means it is transitive also. That means this relation is definitely equivalence for all the triangles. For all the triangles. Okay. Now, next part says, consider three triangles T1 with sides 3, 4, 5, T2 with sides 5, 12, 13 and T3 with sides 6, 8, 10. Which triangles among T1, T2 and T3 are related according to this relation? So, related means two triangles which are similar. By 3, 4, 5 and 5, 12, 13. All three are right triangles. Obviously, if you remember Pythagorean triplets, 3, 4, 5 is a Pythagorean triplet, 5, 12, 13 is a Pythagorean triplet and 6, 8, 10 is also a Pythagorean triplet. So, all three are right angles, right triangles. But are all right triangles similar to each other? Is every right triangle in the world similar to each other? No, right? It's not, right? This right triangle and this right triangle are not similar to each other. Correct? But here, 3, 4, 5, if you multiply with 2, 3 into 2, 4 into 2, 5 into 2, we get 6, 8, 10. So, ratio of sides is equal. That means 6, 8, 10. That means T1 is similar to T3. That means according to this relation, only T1 and T3 are related. T2 is not related. There you'll write, according to this relation, only T1 and T3 are related. T2 is not related because this T2 ratio, sides ratio is not going to be equal. 5 by 3 is not equal to 12 by 4 is not equal to 13 by 5. They are not similar. They are right triangle, but they are not similar. Okay. So, similar triangles condition is ratio of sides should be equal. Proportion of sides should be equal. So, according to this relation, only T1 and T3 are related. Okay. Writing, while explaining the question, whatever is given, write that. First write given thing, what is given, then write the definition of reflexive, transitive and symmetric, and then you can write in your own words that why is it reflexive, why is it symmetric, why is it transitive. No need to write in mathematical language also, that will also be accepted. Don't worry about it. Okay. And this is how for 2, 3, this can be asked in even 5 marks. So, it depends how much you need to write. If it comes in 3 marks, then just write the definition and write that this is reflexive, symmetric and transitive. Okay, that much is okay. If 5 marks, then explain also. So, it depends on amount of marks that how much you need to explain. Generally, for a 3-mark question, half page should be covered. And for a 5-mark question, more than 1 page or at least 1 page should be covered. Then you are going to get 5 marks. It does not mean that to cover 1 page, you are just going to write 3 lines in 1 page. Don't do that. Okay, that is not going to be accepted. Alright, let's see this. This is also a repeated question, and on the basis of this question, many questions, similar questions are made from in CBSE. Alright, let R be A comma B, where A comma B belongs to Z. That means all the integers are there. That means all the integers. And A plus B is even. What is the relation? Relation is of elements A, B, where A and B are integers and A plus B is even. Show that R is equivalence relation on Z. Try doing that. Try writing it in your own words first. I'll just be back in a minute. Try it. I'll just drink water and come. Try it for 2 minutes. Write completely. How will you show it? Okay, write completely in your notebooks. How are you going to show this? Voice should be okay. Yeah. Okay, done. I hope you have solved. All right, I'm going to move ahead. Now, we have to show that it is equivalence. This can come in 5 marks. This type of question can come in 5 marks. So, you have to show properly. Okay, write all the statements, all the definitions of transitive, reflexive and symmetric and show that it is going to be true for all. A and B both belong to the real numbers. That means it is the relation from all the real numbers to all the real numbers. Okay. Now, is it going to be reflexive? Right? Writing part, for R to be reflexive. For R to be reflexive, write the definition. Okay, here write the definition of reflexive function first. Okay, right? Now, given, write before this, write given. In given, write the same statement. Okay, in given, you have to write the same statement, then write for R to be reflexive, what is the definition or what is the condition for a relation to be reflexive, that you have to write. Now, as all A comma A will belong to R. All A comma A will belong to R for all A belonging to Z. Right? As for all A comma A belonging to R, for all A belonging to Z, that means for all the integers, A plus A will be equal to, or here you can write A plus A will be equal to 2A, which is even. Right? 1 plus 1 is even, 2 plus 2 is even, 3 plus 3 is even, 4 plus 4 is even, 5 plus 5 is even. Right? For A plus A will be equal to 2A. That means A comma A will belong to the relation. For all A belonging to Z, or you can write like this also, for all A belonging to Z, A plus A is going to be equal to 2A, which is even. That's why all A comma A will belong to your relation. Right? For all A belonging to Z, A comma A will belong to your relation. That means R is reflexive. That means R is reflexive. Or you can write hence. Right? Write some more lines. This is, I'm just keeping it short for the space. Write some more lines if it is a 5 marks question. R is definitely reflexive. Now, R to be symmetric. For R to be symmetric, right? If A plus B, for write again, for R to be symmetric. Again, write the definition of symmetric. Right? Write the definition. Write the definition. Now you tell, if A comma B for all A comma B, where A comma B belongs to Z, if A plus B is even, if A plus B is even, if 1 plus 3 is even, then 3 plus 1 is also even, right? A and B will belong to R only if A plus B is even. If A plus B is even, then B plus A is also even. Right? So, if A comma B belongs to Z, then B comma A, if hence, therefore, you can write therefore, if A comma B belongs to R, then B comma A will also belong to the relation, because if A plus B is even, then B plus A will also be even. Correct? So, this is the second statement. Third, for R to be transitive. Right? Write the third thing. Again, definition. Again, write the definition of transitive function. Definition you must write in a 5 mark question of reflexive, symmetric and transitive. Right? Write the definition. Now, if A plus B is even, or you can write like this, for A comma B belonging to R, A implies that A plus B is even. Right? This is given. And if B comma C is also belonging to R, then B plus C is also even. Right? B plus C is also even. Now, what do you need to prove? This is to given. This is already given. What do you need to prove? That A comma C should also be even. A and C should also be even. Now, A plus B is even. This is even. Write like this. Since, or you can write since A plus B is even and B plus C is also even. Add both of these. A plus 2B plus C will be even, because even plus even will always be even. Right? A plus 2B plus C will also be even. Even plus even will also be even. Now this 2B is even. This 2B part is even. So I can say A plus C will be equal to even minus 2B. And 2B is also even. Even minus even is also even. 2B is even only, no? Where, or you can write where 2B is even. You can write 2B is even. Right? If even minus even will also be even, that means hence A plus C is even. Right? So hence, now write hence A comma C also belongs to R, and hence the function is transitive. This is how you have to write for a 5 marks question. Right? If A plus B is even and B plus C is even, if A comma B belongs to R and B comma C belongs to R, that means A plus B is even and B plus C is also even. And in that case, we can simply prove in 3 steps that A plus C will also be even and A comma C will also belong to your relation. As simple as that. Don't forget to like the session and subscribe if you haven't till now. Right? That's a mandate. This is how you have to write. This is how you have to prove. Simple question. Now, all the other questions are of the similar type. For example, this x belonging to z, where x is between 0 to 12, including 0 and 12 also. Show that R, A comma B, where mod of A minus B is divisible by 4 is an equivalence relation. Achha, 0 is divisible by everything. Right? 0 is divisible by 0 by anything is 0. So, 0 is divisible by anything, any real number. Okay. Mod of A minus B is divisible by 4. This is the relation. What is the relation? The relation is between A and B, where A comma B belong to your main set, which is this, between 0 and 12. A minus B, mod of A minus B is divisible by 4. This is the relation. Is an equivalence relation. Is an equivalence relation. And one more thing is asked here. Also write the equivalence class of 2. Equivalence class is introduced over here, and the definition is also written. What is the meaning of equivalence class? Equivalence class is only defined in the case of equivalence relation. Otherwise, we don't talk about it. Okay. So first we'll have to show that it is an equivalence relation, and in that we'll show the equivalence class of 2. What do we mean by the equivalence class of 2? A set of all elements related to A is precisely what defines the equivalence class in mathematics, typically denoted as A, where A is the reference element within the given set and relation is an equivalence relation, meaning all elements that set are in the set are considered equivalent to A according to the defined relation. Too much. Okay. In simple words, all the elements in this relation which are going to be related from 2, that are going to be there in the that is going to be the equivalence class of 2. I'll show you how. Let's do step by step. First of all, whether this is equivalence or not, how will we show it? Now, for all 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 5, mod of 1 minus 1, 2 minus 2, 3 minus 3, 4 minus 4, 5 minus 5, all these mods will give you 0, and 0 is divisible by 4. 0 is divisible by every number, so 0 is divisible by 4. So you can simply write in your own terms that for all A belonging to the set A, for all A belonging to set A, or for all X belonging to set, for not X, for all A belonging to set A comma A will belong to R as A minus A, mod of A minus A is equal to 0, which is divisible by 4. So this is definitely a reflexive function. Then comes symmetric. Okay. If A minus B is divisible by 4, then B minus A will also be divisible by 4 because there is mod. Even if mod was not there, then also. If 10 minus 2 is divisible by 4, then 2 minus 10 is also divisible by 4. Correct or not? Right? For all the, what will be the elements? This set A will contain, what will be the elements in set A? Elements in set A will be 0, 1, 2, this also you can write, till 12. Okay, all these elements. Right? If 1 comma 2 is present in this relation, no, because 1 minus 2 is not divisible by 4. Is 1 comma 5 present in this relation? Yes. Relation will contain 1 comma 5. Correct? Because 1 minus 5 is divisible by 4 and 5 minus 1 is also divisible by 4. So now from here you can take out the elements also. Right? So relation will contain which elements will be there in the relation. If you want to solve like this way also you can solve and explain that which elements will be there in the relation. 0 comma 4 will be there? No. Yes, sorry, 0 comma 4 will be there in the relation. 0 minus 4 is divisible by 4, 4 minus 0 is divisible by 4. 0 comma nothing else. 0 comma 8 will be there. Right? Then 0 comma 12 will be there. So you can write the elements also, you can check. Although this much you don't need to write if it is a 5-mark question also. You don't need to write all the elements. You have to, in your mentally you have to think that, yeah, acha, these elements will be there in my relation which are divisible by 4. The ordered pairs which are divisible by, ordered pairs of A comma B which are divisible by 4. Yes, this will be enough, champion. Definitely yes. All this will be enough. Apart from this, just do some sample papers. From there also relation function questions and that will be done for you. That will be suitable for you. Okay. So, correct or not? If A minus B is divisible by 4, then or for showing it symmetric, you just need to write if A minus B is divisible by 4, then B minus A will also be divisible by 4. Right? Because if I'm writing, I can write like this, A minus B is equal to 4k. Let's say A minus B is divisible by 4. Then B minus A will be equal to minus 4k, which is also divisible by 4. This way also you can write, or in the simple terms you can write. Now, third thing is transitive. How to show whether it is transitive or not? Same way we did over here. Same way we did over here. If A minus B is equal to 4k, we'll simply write like this. If A minus B is equal to 4k, right, mod of A minus B is equal to 4k, and mod of B minus C, k1 over here and this is k2 over here. Then mod of A minus C can be written like this, A minus B plus B minus C. Can we write like this? Mod of A minus B can be written like this. Correct? So this is what? A minus B is 4k1 plus 4k2 will be equal to 4 times of k1 plus k2, and it is divisible by 4. That means A minus C will also be divisible by 4. This is how you can show in your explanation. Right? These are the simple steps in which you can prove, show or check on your own also. Right? If A minus B is divisible by 4, then we can write it as 4k1. B minus B, C. So what is the condition for transitive? That if A comma B belongs to R, when will A comma B belong to R? When A minus B is divisible by 4 and B comma C belongs to R, then it implies that A comma C should also belong to the relation. B comma C will be in the relation when B minus C is divisible by 4. These two are given things. This is given to you and this is to prove. This is to prove. To prove that A minus C is divisible by 4, or in between you can write to prove A mod of A minus C is divisible by 4. Then only you can say that your A comma C also belongs to R, because A minus C will be divisible by 4, and this is how you can prove it. You can just simply write A minus C as A minus B plus B minus C. Minus B plus B are nullified. So this will be 4k1, this will be 4k2, 4 times of k1, k2, k1 plus k2. That means A minus C is also divisible by 4. That means A comma C belongs to R. That means this relation is also transitive. If it is transitive, symmetric and reflexive, that means it is your equivalence relation. Now, second thing is find the set of all elements related to 1. Find the set of all elements related to 1. That means in A comma B, what does this mean? That means 1 comma B should belong to R. If it belongs to R, that means 1 minus B should be equal to 4k. Okay, 1 minus B should be equal to 4k. That means, right, this is how you will prove. That means 1 minus B should be equal to 4k. Now think, how will you show that? Now what all elements can be related to? What all elements can be related to your 1? That means 1 will be equal to B plus 4k. So k, put k is 1, 2, 3 and 4, right? So from 1, if you look at these, if we look at our main relation also, what are the elements? 0, 1, 2, 3, 4, 5, 6, 7, 8 and till 12. These are the elements in our set. These are the elements. What all elements can I relate to 1? If I want them to relate to 1, 1 minus some other element mod should be equal to 4k. Should be a multiple of 4. That means 1 minus 2, can you do that? No. 1 minus 3, minus 2, no. 1 minus 4, 3, no. 1 comma 5. That means 1 comma 5 is a relation. So from 1, so if I want to write the equivalence class of 1, equivalence class of 1 means all the elements which are related from 1. All the elements which are related from 1. From 1, which one can I relate? I can relate 5 because 1 minus 5 will be divisible by 4. 6, no. 7, no. 8, no. 9. I can relate 9. 1 minus 9 is 8, which is divisible by 4. After this, 1 minus 11, 1 minus 12, 1 minus 12 will be 11. So equivalence class of 1 will be just 5 and 9. Similarly, equivalence class of 0. 0 minus 4 is divisible by 4? No. 0 minus 5, yes, 0 minus 4 is divisible by 4, obviously, correct? So 4 comes in equivalence class of 0. This is how, just learn this. Equivalence class means this symbol and the elements which are related from 0. So from 0 I can relate 4, 8 and I can also relate 12 because 0 minus 12 will be divisible by 4. So from 0, which ones can I relate? I can relate 4, 8 and 0. One more thing, you can also relate 0. 0 minus 0 is also divisible by 4, right? So 0, 4, 8, 12 will come in your equivalence class of 0. Equivalence class of 1 will be 5, 9. Similarly, if I ask you equivalence class of 2, so from 2 you have to start. 2 minus 3, no. 2 minus 4, no. 2 minus 5, no. 2 minus 6, yes. So equivalence class of 2, first element will be 6. Then 7, 8, 9, 10. After 4 only it will come. 2 minus 10, which is 8. So that will also be related. After this, nothing. 2 minus 12 is 10. So equivalence class of 2 will be 6, 10. These will be the elements in equivalence class of 2. That's how you have to write. That's it. Very simple. Equivalence class is very simple. Very rarely they have asked, but yeah, they can ask you this type of question also. Alright, let's move ahead. Now, let R, one more question. Same type. Equivalence class of 0. Right, this try on your own. Here equivalence class of 0 they are asking. These are the elements. So from 0, just simply look over here. If I want to simply write equivalence class of 0, right? If I want to write equivalence class of 0, write the equivalence class of 0. Now, if it is a 3 marks question or a 5 marks question, although very less chances, 0 minus A should be, 0 minus A or 0 minus B should be equal to 2 times of k. That means it should be divisible by 2. 0 minus some b should be divisible by 2. Now b can be, what can be b? B can be 0, 1, 2, 3, 4 or 5, right? So now this 0 will be equal to 2k plus b. 2 plus 0, so k, start k from 0. 0 plus 0, that means yes, in equivalence class of 0, 0 will come because 0 minus 0 is divisible by, 0 can be written as 2 into 0 plus 0, right? Now 2 into 1 plus 0, yes, you can write. So 2 will also be there in equivalence class of 0 because 0, 2, where 2 divides a minus b. 0 minus 2 will be divisible by 2, so 2 will be there. Now 3, 0, 3 can be there, 0, 1 not there, 0, 2 can be there, 0, 3 can be there. 0 minus 3 is not divisible by 2. So that means 3 cannot be there. 0, 4 can be there. Yes, 0 minus 4 is divisible by 2. So 4 will be there in equivalence class of 0. 0 minus 4 is divisible. 2 divides a minus b. 0, what is your a? A is already fixed, 0, right? And b is all these. B can be anything of these. So 0 to 4, then 6, then 6 is not there already, right? So 4, that's it. So equivalence class of 0 will be 0, 2 and 4. 0 can be related to 0, 0 can be related to 2, 0 can be related to 4. So equivalence class of 0 is these 3 elements, which is 0, 2 and 4. Alright, this is how you are supposed to explain in the exam. Now, depending on the marks, you can exceed the length, however you want to do it, right? The main concept is that equivalence class means all the elements which can be related to 0 according to this particular relation. You can write in your own words, write in given, proof, to proof, all that you can do on your own. But this is going to be the main concept, and answer will be 0, 2 and 4. Again, it's the same question. This question is repeated, right? This question is very important. Equivalence class, only 2 types of questions have come. Only this type of question have come. Show that the relation is given a minus b is even, right? A minus b is even over here is an equivalence relation, right? We did for 4, we did for 2. Now we can do this very easily. First thing, reflexive. 1, 1 will be present because 1 minus 1, 0, 2 minus 2, 0, 3 minus 3, 0, 4 minus 4, 0, 5 minus 5, 0. So that means 1, 1, 2, 2, 3, 3, 4, 4 and 5, 5 can be present in this relation, because these all satisfy the condition. 0 is divisible. Now, second, if 1, 2 is present, then 2, 1 will be present. 1, 2 is not going to be present, right? 1, 2 will not be present because 1 minus 2 is not even. 1, 3 can be present. And if simply write this. If a minus b is even, then b minus a is also even. That means this relation, that means if a comma b is present in the relation, then b comma a is also present in the relation. Write in the terms of variables only. If it is a 3-mark question, definitely. Don't take the elements and then write it. How long is the session? Beta, just some more time, okay? After relations, we'll do functions, and ITF is a small part, very small part, okay? Don't worry, right? And same way, if a minus b is even, b minus c is even, then a minus c will also be even. We have seen how to prove that. So this type of questions are very, very important. Practice these, okay? One is this. This type of question can also be asked. This has also been asked in mains and in boards also. They ask this. So now what are they saying? The relation is on n cross n. N means natural numbers defined by a comma b related to c comma d, right? N cross n, relation is from n cross n to n cross n. N cross n itself will have 2 elements, right? Relation is on n cross n. Suppose n is this, right? A, B, C, D, something, let's say 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5, right? This is also n, 1, 2, 3, 4, 5. Relations is defined from n cross n. That means 1, 2, 2 related to 2, 3. This is how you are going to write. This is the relation. 1, 2 to 2, 3 is defined as 1 plus 1, sorry, a comma b to c comma d is defined as a plus d and b plus c. A plus d equal to b plus c. If your a plus d is equal to b plus c, then relation can be defined. Okay. For example, in this only 1, 2 will be related to 2, 1. Correct? 1 plus 2, 1 plus 1 will be 2 and 2 plus 2 will be 4. No, this will not work over here. This will not work over here, right? So you have understood what I'm trying to say. I'll just show you how will this be an equivalent relation. Let's not get into example. Simply let's understand how theoretically. Being alone in the chat. Yeah, it's okay. It's okay. So what to worry about, beta? It's okay. It's even if somebody watches it later and gets benefited from this, that's okay for me. All right. Now, if a comma a is present, then and B comma B is present, right? A comma A is related to B comma B, right? This will be, this is how we are going to do it for reflexive, and A comma B, B comma C for transitive. So now try, you have understood the relation, now try to write it in your own words. Try to write it. Try to write it now itself. Done? I hope. Okay. Now, how to write? Simply just for R to be reflexive, for R to be transitive, for R to be equivalence. That is the way you are supposed to write this particular solution. Now, for R to be reflexive, for R to be, so here you can write depending upon how many marks are allotted for this. For R to be reflexive, write the definition. For R to be reflexive, write the definition. This element should be related to itself. That means A comma B should be related, we should be able to relate to A comma B itself. For R to be reflexive, A comma B related to A comma B should belong to your relation, main relation. Should belong to the relation. And yes, we can see if A comma B is related to A comma B, then A plus B, this from this will be equal to B plus A. Yes. And here you can write due to commutative property of addition. This is always true for all A comma B belonging to natural numbers, right? For all A comma B belonging to natural numbers, this is going to be true. A comma B will be equal to A plus B will be equal to B plus A for all A comma B belonging to natural numbers. So this is definitely reflexive. Now for R to be symmetric, right? For R to be symmetric, what relation we'll find? A comma B should be related to B comma A, right? A comma B should be related to B comma A, and this relation should belong to your main relation, which is R. This is how you'll prove, correct? Now, if A comma B, we are relating to B comma A, that means A plus A will be equal to B plus B. Sorry, something. Oh, sorry. Wrong we are writing. If this relation, according to symmetric, if A comma B related to C comma D belongs to relation, then C comma D related to A comma B should also belong to your relation. This is given, right? And this is what you need to prove. And here you can simply see C plus B will be equal to A plus D. Outer to outer, A plus D and B plus C. So C plus B will be equal to A plus D. Correct? So that means it is going to be symmetric also. This will be true. This will be true or not? If A plus D is equal to B plus C, then that means C plus B will also be equal to A plus D. Correct? Arey bhai, only reverse direction only I have written. No, this can be also written as B plus C equal to A plus D. So this will also be true. This will also exist. If this exists in the relation, then this will also exist in the relation. That means it is symmetric also. Correct? Transitive. Now transitive. For transitive, what you will have to write? For R to be transitive, if A comma B related to C comma D belongs to the relation and C comma D related to E comma F, you have to take one more, is also there in the relation, then this implies that A comma B related to E comma F should also be there in your relation. That means we have to prove that A plus F should be equal to B plus E. This is to prove. This is what we need to prove, that this will also be true. What does this relation gives us? We know that A plus D is, this relation gives us A plus D equal to B plus C, and this relation gives us C plus F equals to D plus E. Correct? Now, if we'll subtract these, we can simply prove that A plus F will be equal, or we can add also, no problem, we can add also. Oh, sorry. Yeah, we can add also. Let's say we are adding. So, A plus D plus C plus F will be equal to B plus C plus D plus E. Now, D will cancel D, C will cancel C, and A plus F will be equal to B plus E. This is what we were supposed to prove, that this will also belong in the relation. That means it is also transitive. This relation is also transitive. Watching Unacademy, sir, I have completed my... Very good, YTGT. So proud, so happy for that, so happy for you, right? That's very good. Okay, so this is transitive. So now you know statements, writing, everything, how to prove. This last question was also very important. Okay, try writing this in your own words on your own. I've explained how to prove. Now write it in your own words as a 5-mark question. This can definitely come in a 5-mark question, and I think that this time the math paper, because physics was also hard and math has holidays, so definitely math, especially applied mathematics paper, is going to be difficult. Difficult than the previous years. That is what, or difficult than your expectations. Next thing is function, right? In relation, these all types of questions can be asked from you. Now we are moving towards function. When can we call a relation as function? Two conditions are there. Suppose if we are doing, there is a function which is the function of A to B. The function is from A to B, right? And if we want to call this relation as function, suppose relation is from A to B, and we want to know that when can we call a relation as function? When all the elements of A, suppose A1, A2, A3, A4, these are the 4 elements, and here we have B1, B2, B3, B4, and let's say B5. If all the elements are related to, all the elements of the left side are related to any one of the elements of right side, but we cannot miss any of the elements of the left side. Any element of A cannot be missed, right? If we are covering all the elements of A and relating to the right side, that means in this case we can call this as a function. In this relation can be called as a function because every element of left side is mapped to the element on the right side. A relation is called a function when each input value, that means input values are these, is associated to exactly one output value. Yes, one more condition is there. if two input values are associated, suppose in this case only, suppose I relate two input values to same output value, then also this will not be called as a function. This will also not be a function, right? So every element from the left side should be related to one element from the right side, right? Every element should be related to one element from the right side, exactly one element from the right side. For example, suppose this is the case that this is related, this is related, this is related, this is related. These are not related, no problem. All the elements of this side are covered, and all these are, no two elements of the left side are related to single element of the right side. No two elements of the left side should be related to single element of the right side. Then only we can call this relation as function. What are the conditions? Read again. A relation is called as function when each input value is associated with exactly one output value. In other words, for every x, there is only one corresponding y. If for 2x there is single y, then that is not called a function. That relation cannot be defined as function. If for 2x there is single y, then in that case we cannot define it as a function. Okay. So suppose if I relate A4 and A3 both with B3, then two values of left side are associated with single. Two inputs are giving the same outputs. That means this is not a function. This relation cannot be called as a function. Okay. Now about types of functions. So what are the types of functions? Two types you have to learn: one and onto. Right? Two types of functions. If a function is not 1, then it is called many one. If a function is not 1, then it is called many one. If a function is not onto, then it will be called into. Okay, this is one thing. Now, 1 function is also called as, 1 function can also be called as injective. Okay, onto function can be called as surjective. One function can be called as injective and onto function is called as surjective. And if a function is both, if a function is 1 as well as onto, if a function is 1 as well as onto, then it will be called as bijective. So they can ask you questions based on this also: injective, surjective, bijective. Okay, so remember, if a function is 1 as well as onto, then you can call that function as bijective. If the function is 1 it will be called as injective. If it is only onto, then it will be surjective. And both 1 and onto, that means it is a bijective function. These names you should remember, you should be familiar with. If okay, I have written and n. Okay, so I'll write like this: not 1 or not injective, that means it is going to be called as many one, right? If it is not onto means it is called as into function. So you just have to check for 1 and onto. Now how to check? Suppose we have A1, A2, A3, A4, A5, okay, and we have B1, B2, B3, B4, B5, B6, B7. Let's say this is set A, this is set B, and a function is from A to B. The function is from A to B, and function is defined like this: A is, okay, if every element of left is giving you one element of right, then it is 1 function. If one element of left is giving you two elements from y, suppose if this A4 is related to B4 also and B6 also. This can happen, right? I said that two elements of left cannot be related to one of y, then it will not be function. But any one element of left can give you two values from y, minus 2 square, right? X square is equal to 4. So plus and minus 2 both will be related, right? That can happen, right? One element of left is giving you two outputs. That means this is many one. This is not one one. For one one, every element of left should give you only one output. Should be related to only one element of the right. In this case, it will be called as 1 1. Onto means if all the elements of the right side are related from the elements of the left side, all the elements of the right side. Now over here, if I explain you simple thing, over here this thing is called your domain. This thing is called as your codomain. Now for this one, if I talk about domain, for this particular function, domain will be what? What will be the domain? Domain will be these elements A1, A2, A3, A4 and A5. What will be codomain? Codomain will be B1, B2, B3 until B7. Okay, all these. Now what will be the range? Range. What all outputs can you receive? What all outputs can you receive? Range is different than codomain. Range over here is B1 to B5 only. B1, B2, B3, B4 and B5. This is your range. Now, if in any case range and codomain both are equal, that means every element of left is related to every element of y. Every element of right. All the elements are right. In right are related. Right? Sir, admit cards are open. Is admit cards open? Not sure, but I have to check. Right? Rukmini, I have to check. I'm not sure. Right? Every element of left is giving you all the elements of right are there in the output. In that case, your range will be equal to codomain. And if range is equal to codomain, in this case, you can say that it is a onto function, otherwise into. Here in this case, this is into. Now, suppose if I do this also, then also it is a onto function now, because all the elements of right are covered. 2 of left cannot give you 1, but any 1 from left can give you 2 outputs, right? 2 inputs should not give you 1 output, then it will not be a function. But any 1 input can give you multiple outputs. Now this is an into function. Why? Sorry, this is an onto function now. Before this, if I remove these two, now this is an into function, right? Because range is not equal to codomain. Okay, let's understand with the help of questions and some definitions also. A function x to y is defined to be 1 1 or injective if the images of distinct elements of x, all distinct elements of x under f are distinct. That means every element of x is giving you a distinct y. No two are giving you same y. No two elements in x are giving you same element of y. In that case, it will not be a 1 1, otherwise it will be 1 1. Okay. Otherwise, it will be 1 1. So basically, every distinct element in x should give you an output in y. Every distinct element in x should give you an distinct output in y. Suppose if A1 and A2 are related to, sorry, this cannot happen. Suppose if A1 and A2 are there and here we have B1, B2 and B3, right? If this is the case, then it is 1 1. No problem. Every distinct element of left is giving you distinct output from right. This is 1 1. But if I do this, now this became many one. One element is giving 2 different outputs. Right? Now this became many one. And if I do this, now this is not even a function. 2 outputs cannot give a same, 2 inputs cannot give the same output. Right? So every distinct element of left should give you a distinct element from right. And how to prove this? In the proving questions, you will have to use this. In the proving questions, note this down. For proving, you will just use this statement. If fx1 If we take f of x1 equal to f of x2 and this gives you x1 equal to x2, then that function is going to be 1, 1. Now come to onto. A function is onto or surjective. X comma y is x to y, function x to y is said to be surjective if every element of y is the image of some element of x. That means all the elements of y should be an output from all the element, any element of left of x. Okay, any element of x. That's it. That means all the elements in your codomain should be covered as the range, or simply we can say voice. Yeah, I hope it's clear. So I'm saying that. So I'm saying that. How to prove that? Here, use the concept that codomain is equal to range. If your codomain is equal to range, I'll tell you how, I'll show you how to do this. But for now, remember two things. For proving 1, 1, you just need to do this. Take fx1 equal to fx2 and then solve. And if you are getting x1 equal to x2, then your function is 1, 1. If you are getting x1 equal to x2 plus some additional thing, then it is not 1, 1. Right? And for proving it as onto, just prove codomain equal to range. If you are able to, if that is the case, then it is an onto function. Otherwise, it is into. Function x to y is onto if range of f is equal to y. That's what. Range is equal to codomain. Y is what? Y is your domain. Sorry, y is your codomain. Range of function. Range of function, that means all the outputs. If those are equal to your codomain, that means your function is onto. Okay. 1, 1, if 1, 1 and onto both, if both, then that means your function is bijective. 1, 1 and onto both means function is bijective. This word bijective is going to be used a lot in the questions. So remember, bijective means 1, 1 as well as onto. Alright. So let's move ahead to the questions. Okay, some examples. Yeah, this is from your NCERT only. Now check which function is 1, 1. Which of the functions is 1, 1? Every element of left should be related to distinct element of y. 1 is related to A, 2 is related to B, 3 is related to D and 4 is related to C. So this is, can we write it 1, 1? Right? Is it onto all the elements of y? All the elements of your codomain are not being covered. All the elements of codomain are not the output from the elements of your domain. Right? All these are not covered. All these are not related from left. So this is not onto. Or we can write not onto, 1, 1 and into. We can write not onto, that means into. This is 1, 1 and into. Now this one. 1 is related to okay. This should not be even a function. Is second one, is f2 even a function? Check once. Is your f2 even a function? Check. Check for 1, 1 and onto on your own once. I'll just be back. This is not even a function. Correct? Why? Because 2 of the left are related to single element in right. So this is not even a function. This is not a function. Now check. Is this a function? Yes. Is this a function? Is this a function? x1 to x2. Check for all 4 of them. I'll just drink some hot water and come back. Sorry, I've written wrong over here. Right, this is wrong. Two elements can give you single output. No, this should not be the case. 4 should not be related to two different. One element should not be related to two different elements. Okay, that is the case. Then only it will not be called as a function. I think I said wrong somewhere. Huh? Did I write anything wrong? Huh. Every from left should be associated to every one output, right? It is a function. Why not a function? I was saying vice versa. I was saying ulta actually, right? Every one of left should not be related to 2, right? So this will be function. All are functions. Why not a function? Okay. This is 1 1 and into. Now this one, every one of the left is related to one from the right. All the elements of the left are related to any one element of the right. No, this is not 1 1. Not 1 1. Why not 1 1? Because two elements of the left are related to single element of right. So not 1 1. Okay. Now let's see 1 1 or not 1 1. This is also not 1 1. This is also not 1 1. Every element of left is related to a different element of right. So this is 1 1. This is your 1 1 function. Right, any single element of left should not be related to two different elements of right. If I said something wrong previously, please don't mind that. Okay, I think maybe I confused you. Before I was saying 2 from left should not be related to right, but it is any one single element of left should not be related to two different elements of right. I gave you the example, right? Minus 2 square is also 4 and 2 square is also 4. So 4 is related to minus 2 and 2 both. That is why it won't be a function. Now this case not 1 1. This is 1 1. Now about on 2. All are not covered. So into. Here are all covered? No. So this is also into. All are not covered. Right? Codomain is not equal to range. Here all the elements are related from left. So this is your on 2. All the elements of right are covered. All the elements of right are related from left. So this is also onto. Bijective. Which ones will be bijective? 1 1 and onto. 1 1 and onto. So this will be your bijective. This is also bijective. Both 1 1 and onto. That means that function will be bijective. This function is 1 1 as well as onto. This function is not 1 1 and into. Okay. I think I explained something wrong. Yes. Hi Shaurivir, how are you? You have exams. What are you doing here? Okay. Now let's do some question. Function. I hope this was clear and I did not. If there was any confusion, please pardon me for that. This was clear. No one element should be related to two different elements from the right, on the right. Then it will not be called as a function. Suppose if 4 was related to C as well as F. In this case, it will not be called as a function. If right, otherwise it is a function. Every element of left is giving you an element of right. One element of left is not connected to or is not related to two different functions, two different elements of right. In that case, it will not be called as a function. All right. Now over here, the function R to R is defined by f of x is equal to function of real numbers to real numbers is defined by f of x is equal to 4 plus 3x. Will this be bijective 1 1 onto, not onto, whatever? What is the case? Come on, tell me the answer. Tell me the answer. But x can take all the real values, right? X can take all the real values. Now your 4 plus 3 cos x, maximum value itself will be equal to 7 because maximum value of cos x is 1, minimum is 1, minus 1, maximum is 1, right? So maximum value of this function will be 7. Whatever real number you put on the right side, on the left side, so this will be your left function, right? This will be your left function. This 4 plus 3x, 4 plus 3 cos x will be your left function and right function will be your f of x. Correct? This only is y. No, this is output, this is input, input, output, right? Now you tell me all for every value 4 plus 3 cos x, will give you a different value in y. All the values over here, whatever value you put for x, 1, 2, 3, 4, 5, 6, whatever you put for x, pi by 2, any real number you put for x, it will give you a value on the right. And one input will not give you two different outputs. One input will never give you two different outputs. So all of these will be related, right? So that means it is going to be a 1-1 function. It is going to be a 1-1 function. Onto means all this is also R, here also R, here also R. What is the codomain? R. That means all real numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 till infinity. But what is our range? What is our range? That means what are the possible values of f of x? From from 1 to 7. Right? This cos x can be -1 to 1. So values will be from 1 to 7. That means maximum only it can be 7. That means whatever elements are here will be related only till 7. That means codomain will not be equal to range. Codomain will not be equal to range. Right? If this is the case, then it will not be onto. That means it will be 1-1 but not onto. And it cannot be bijective obviously. So it will be 1-1 but not onto. Solve more, shall we? Solve more. The number of functions defined from which are 1-1 function. How many functions? Next question, which is objective. Number of functions defined from this to AB which are 1-1 functions. Tell me, what should be the answer? 4 options are there: 5, 4, 5, 3, 2 and 0. This is your domain, this is your codomain. So 1, 2, 3, 4 and 5. And here we have A and B. 1-1 function. How many functions can be 1-1? For it to be a function, first of all the elements of left should be related to right. Correct? All the elements. But now here only 2 elements are there. Here 5 elements are there. How will you relate the remaining elements? Your 3 will also relate to A. Your 4 will also relate to A, or 5 will relate to B. Now you'll have to call it a function. Otherwise you cannot call it a function. Every element of the left should be covered. But in this case, can it be 1-1? No. Every distinct of left should give you a distinct from right, a distinct element from right. Here 3 and 1 both are giving you A. Here 2 and 4 will give you. However, if you want to call it a function, you'll have to at least relate 2 elements of the left to any one element of the right. You'll have to do that. So it cannot be 1-1. There cannot be any 1-1 function over here. That means the answer is 0. 1-1 function means, right? Suppose if we had more functions, if we had 5 functions over here, then we could make 1-1-1 function. Right? Then we could make 1-1-1 function. Otherwise, we cannot make 1-1 function. Right? So 3 also you'll have to relate to A or B. 4 also you'll have to relate to A or B. Right? Then only it will become a function. All the elements of left should be covered. And in this case, it is becoming your many one function, because 1 and 3 both are related to A, 2 and 4 both are related to B, 1, 3 and 5 are related to A. So this is a many one. We cannot form a 1-1 function from here. So that means 0 will be your answer. So these type of objective questions can be asked. Over here, show that F is bijective or bijection. F is bijective or bijection. N belongs N to N. Function is from N to N. Right? Function is from N to N. Now we have to show. Suppose this comes in 2 marks. Okay. We have to show that your function is a 1-1 as well as onto function. How will you prove? Come on, try it. Now, if it comes in 2 marks, if it comes in 2 or 3 marks, and mostly it will come in 2 and 3 marks only. Suppose your N to N you are making. right? N to n you are making 1, 2, 3, 4, 5, all the elements, all the natural numbers, and here also n, 1, 2, 3, 4, 5, 6, all the elements. Okay. Now let's take n as 1. Suppose n is 1. Suppose we are taking n as 1. First natural number, 1 plus 1 will be equal to 2. So 1 will be related to 2 because 1 is odd. Now take 2. 2 minus 1 will be equal to 1. So 2 will be related to 1. Then 3. 3 is odd. So 3 plus 1, 4. 3 will be related to 4. 4 is even. So 4 minus 1, that means 3. So 4 will be related to 3. Similarly, 5 will be related to 7 and 6 will be related to 5. Correct. So all the elements of left are giving you a different element from right. All the elements, no two elements of left are giving you same element of right. That means this is definitely your 1 1 function, definitely 1 1, right? Every element of left is giving you a different element of right, right? Every element of left is giving you a different element of right. That means it is 1 1, right? You can show like this only. Let n be so if we take n as 1, 2, 3, like this it will come, and so all the elements of left will be giving you a different element from right, and it will be also onto. Why onto? Because you go till infinity, all the elements of right, that means codomain will be equal to range, because everything will be covered. No, natural numbers will go till infinity, so everything on the right will be covered. All the outputs will be covered. There will be no outputs which will be left. Will there be any natural number which cannot be received from n plus 1 or n minus 1? No. All the natural numbers can be received from n plus 1 and n minus 1, where n is either even or odd. That means this function is 1 1 as well as onto. So it is a bijective function or a bijection. Okay, this is all. Same type of question, another year, this way. This way also n to n. So show like this, n, and this is also n. Okay. So now write the numbers, natural numbers only. So 1, 2, 3, 4, 5, 6, like this. 1, 2, 3, 4, 5, 6, 7. Show like this. Okay, if this is actually MCQ, you don't need to show, but just for explanation. Now, if n is even, if n is odd, then output will be n plus 1 by 2. So if n is 1, output will be 1 plus 1 by 2. That means 2 by 2. So 1. 1 be related. Now 2. If n is even, so 2. Let's take next natural number 2. 2 by 2 will be equal to 1. So 2 is related to 1. Okay. Now this will not be 1 1, because two different inputs are giving you same output. Right? Two different inputs are giving you same output. Is my voice clear? Hello, hello. Yes. I have to keep checking it on. So this is not 1 1. This is not 1 1 for sure. This is not 1 1. Two different elements of left are giving you same output from the right. Right? So not 1 1. Is this onto? Now if we keep going on like this, 5 will be 5 and 6 both will be related to 3. If we keep going on like this, do you think every number from the right will be covered? Yes, sir, but from here 2 and from here 1, but it is going to go till infinity. So this is definitely going to be onto. Onto, because codomain, all these numbers on the right will be covered. Codomain will come out to be equal to range. All the numbers from the right will be covered. So it will be not 1 1 but onto. Onto but not 1 1. Option number C should be marked as correct. Okay, let's move ahead. Function R to R, real number to real number, which can be defined as f of x is equal to x to the power 4. All real numbers. Choose the correct answer. F is 1 1 onto, F is many 1 onto, F is 1 1 but not onto, F is neither 1 1 nor onto. Tell me which should be the answer. Come on, think, solve. function is from R, just think like this, function is from R to R. That means all the real numbers and all the real numbers. Think like this, okay. Now, first of all, will this be 1, 1? Will this be 1, 1? Any real number. But if minus 1 to the power 4 is also 1, in these real numbers, minus 1 will also be there, 1 will also be there. In these real numbers, 1 will be there, 2 will be there, 4 will be there, pi by 2, 3.4, anything will be there. But minus 1 to the power 4 is also 1 and 1 to the power 4 is also 1. That means definitely this is not 1, 1. So this is many 1. Many 1, correct? One condition. Two different are giving you same output. Minus 2 to the power 4 and 2 to the power 4 will be same. You can prove like this also, right? So this is many 1. Now on to. Now see, all the numbers are there. 1, 2, 3, 4, 5, 6, all are there. All the numbers are there. No, except natural, pi by 2, pi by 4, 3.4, decimal, all irrational, rational, everything is there. Can you find any number for no R, for no x belonging to R, you can say for no x belonging to R, f of x is equal to 2. Can you tell me for any number for which x to the power 4 is equal to 2? Because 2 is going to be there. And here there won't be any number which will be related to 2, because there is no real number whose power 4 is equal to 2. There is no real number whose power 4 is going to be equal to 2. Or power 4 is going to be equal to minus 2, minus 3, minus 4. Right? So definitely this is not even onto, not onto. Why? Because all the numbers, all the real numbers cannot be covered by this one function. Right? There is no x for which x to the power 4 will be equal to 2. For no x belonging to R, f of x will be equal to 2. X to the power 4 equal to 2, how will you bring that? Or negative 2. You can write, you should actually use negative 2. No, right? For no real number, this is going to be 2. So this is not onto also. So this is many 1 and into. Many 1 into is not written. So this is many 1. F is many 1, onto, not onto also. F is neither 1, 1 nor onto. Option number D will be correct. It's neither 1, 1 nor onto. Okay. This is how you'll have to see and check. Now these type of questions can come for 5 marks from functions, where you'll have to show that this is bijective, or they can ask you show that this is 1, 1 but not onto, or they can ask you show that this is not 1, 1 but onto, anything. So here you have to remember two things, two steps. For showing 1, 1, for showing 1, 1, one is showing 1, 1 and for showing onto. Okay, what are the steps, how to do that? For showing 1, 1, start with taking f of x1 equal to f of x2. Start with this. Okay, start with f of x, taking f of x1 equal to x2. If solve here, solve. If you get x1 equal to x2 in the end, that means it is 1, 1. If you get x1 is equal to x2 and something extra with it, that means not 1, 1. Okay, this is the method of showing 1, 1. Onto, simple thing, separate x and y. Right? First step over here is take f of x. You have to take your f of x equal to y. Then solve. Then what do you say? Simplify. Then you have to simplify by keeping y on one side and x on another. Right? From this, check range of y. Check the range of y. Okay, check the range of y. If this range comes equal to, if this range is equal to codomain, then you can say that is onto, otherwise it is not onto. Let's understand by solving this particular question. Now, to show or to prove, or here we need to check actually. So to check for 1 1, we can write to check for 1 1. What you can do, take f of x1 equal to f of x2. Okay. So if we do that, f of x1, that means 4x1 divided by 3x1 plus 4 will be equal to 4x2 divided by 3x2 plus 4. Cross multiply, what do you get? 12x1 x2 plus 16x1 will be equal to 12x1 x2 plus 16x2. This will cancel this and x1 will come out to be equal to x2. 16x1 equal to 16x2 and x1 comes out to be x2. That means, and here you can write the same line, that remark which I showed you, right? Remember I showed you one remark, this one in the starting questions. This remark you can write, if x to y is onto only if, sorry, not this, this one. For every x1, x2 belonging to x, x1 is equal to f x2 implies x1 equal to x2, implies that the function is 1 1 or injective. That way, this line also you can use to write. Okay. Now, to show, next thing is onto. How to show onto? Onto, first thing is, let y is equal to f of x. That means y is equal to 4x by 3x plus 4. Now, what is your domain and range over here? What is the codomain? This is your codomain. This is your codomain. This is your codomain. Correct? This is your codomain. So, remember, this is your domain, this is your codomain. If codomain comes out to be equal to range, then only you can say this is an onto function. Now, according to this, if we separate everything, so 3xy plus 4y is equal to 4x. So, x into 3y plus 4 is equal to 4x. Sorry, something. Right. So, now take x on that side. So, 4y will be equal to 4x minus 3xy. Right. Take x common from here. You will have 4 minus 3y is equal to 4y. So, your x comes out to be 4y upon 4 minus 3y is equal to x. Correct. Now, this x can be defined for all real values except when y is equal to, here this should not be equal to 0, right? Here 4 minus 3y should not be equal to 0. That means 4 by 3 should not be equal to y. So, y belongs to r minus 4 by 3. Y belongs to, what is your range now? What can be y? What can be y? What was y? F of x. Now, f of x can be anything except 4 by 3. This y can be anything except 4 by 3. Correct? This f of x can be anything except 4 by 3. What was your codomain? This was your codomain. Codomain was R. Correct? Codomain is R. And range is, what is your range? Range is R minus 4 by 3. Are these two equal? No. So, codomain not equal to range. That means function is not surjective or not onto. Okay, function is not surjective, or we can say not onto. You can see, right? What is your range? Range will be, y can be anything except 4 by 3. So, range of y, like range of f of x, that means range of y. What can be the output? Range means output. What can be the possible outputs? Y are the possible outputs. F of x are the possible outputs. But f of x can be anything except 4 by 3. Right? So, range is anything except 4 by 3. But codomain of this function is all real numbers. Codomain is not equal to range. That means this function is 1 1, but it is not onto 1 1 but not onto. So this function is 1 1 but not onto, and in 5 marks this is how you should show it. Okay, for example, this function, right? Try to do this one. Function is defined from minus infinity to 0. This is your, this is what? This is your domain. This is your codomain. Range will get from the function. What are the possible, what can be the possible values of f of x? That will tell us the range. Now, for showing it 1 1, first you will show as 1 1. For showing it 1 1, what will you do? F of x1 equal to f of x2. Now see, your x, what is x? These are all the values of x, and these are the possible values of f of x. So x can be between minus 1 to 0, minus infinity to 0. X belongs to minus infinity to 0, or you can say that x is less than 0, because 0 is not included. X is less than 0, that means x is negative. If x is negative, this function will become x upon 1 minus x, because if x is negative, the mod will open with a negative sign. So this f of x will become equal to 1 upon 1 minus x, right? Now for onto f of x1, we are taking, let f of x1 be equal to f of x2. If we do that, when we solve, we'll get x1 equal to x2. You can try that. 1 by 1 minus x1 will be equal to 1 minus 1 by 1 minus x2. You'll get x1 equal to x2. When you'll solve, you do some more steps and show that x1 will be equal to x2. And if x1 equal to x2 is coming, that means your function is 1 1. For sure it is 1 1. Now onto, what is my function? My function is this much only now, because x ka possible value is between minus 1 infinity to 0. So I can simply take my f of x, let f of x be equal to y. So your y will be equal to what? X upon 1 minus x. Solve this. So y minus xy will be equal to x. So y will be equal to x plus xy. Y minus xy. So y upon 1 plus y will be equal to x. Correct. Now x is defined for all the y's except minus 1. Correct. All the y's except minus 1. But x itself is between, where is your x? Your x itself is between minus infinity to 0. Correct. Your x itself is between minus infinity to 0. That means x is less than 0. And if your x is less than 0, we know our x is less than 0. That means y upon 1 plus y should be less than 0. From here, we'll get the possible values of y or range of y. Right. So now, if you can show in wavy curve method also. So here the root will become minus 1. From here the root will become 0. So plus minus plus. You need minus. So your y belongs to, you need this column. So your y belongs to minus 1 to 0. Because x has to be less than 0. That means y upon 1 plus y has to be less than 0. That means y belongs to minus 1 to 0. And this is our range. And range is coming equal to codomain. Range is coming equal to codomain. The possible values of y are your range. Range is equal to codomain. That means it is a bijective function, 1 1 as well as onto function. How y upon 1 plus y? Can we present the answer as? Yes, definitely studying star. Sir, can you repeat the last step? How y upon 1 plus y? This one. Bhai, take x common. Right? This is what? X into 1 plus y. Now x I am keeping this side. 1 plus y this side. Okay? That's it. What else? Correct? And we know that x has to be less than 0. It is defined here only. This is domain. Domain means possible values of x. X has to be between minus infinity to 0. That means it is less than 0. It is negative. Okay. So this is how. So this was about functions. This method which I taught you is going to be very much applicable. Solve some questions from your NCERT. Solve some exemplar question. Apply this method only for 5-mark question. This is how you are supposed to prove. Take f of x1 equal to f of x2 if you are getting x1 equal to x2. then that means it is a 1-1 function. Most of the cases you'll get 1-1 function. One more thing which I can tell you before starting inverse trigonometric function. A function is invertible only if it is 1-1 and onto. That means only a bijective function can be inverted, or you can say F inverse is possible for bijective functions. F inverse is only possible for bijective functions, or the functions which are 1-1 as well as onto, those type of functions. So this was relation and function, and 99% chances are there that 5 marks will be asked from relation and function, and one objective as well as one 2-mark question can be asked from you from inverse trigonometric functions. Inverse trigonometric functions. Now inverse functions, suppose if your f of x is equal to sin x, then f inverse x can only be defined if sin x is a 1-1 and onto function. Now when is sin x a 1-1 and onto function? You tell me. When is sin x a 1-1 and onto function? Right, sin x is like this, correct? Sin x is like this, 0, pi, pi by 2, and here minus pi by 2, like this, right? Now, but you see, how will it be 1-1? Because on two different x, if I put x as 0 or pi or 2 pi or 3 pi or anything, I am getting output as 0 only. Sin 0 is 0, sin pi is 0, sin 2 pi is 0, sin 3 pi is 0. So it cannot be a 1-1 function. So that is why we say that inverse, sine inverse or inverse function of inverse trigonometric functions are only defined in principal range branch. That means I can only define it in this branch, from here to here, from here to here, minus pi by 2 to pi by 2. F inverse x or sine inverse x exists between minus pi by 2 to pi by 2, because only in this range it is a invertible function. In other cases it is not an invertible function. You do not need to get into all this. For your board's preparation, I am telling you what to do. Only remember the table of range and codomain. Now suppose if your function is from A to B, right, this is your function, then from B to A it will become F inverse. So for F inverse, for F A is domain and B is codomain, or B is range in this case, let's say, because we are saying that it is 1-1 and onto, so B can, codomain will be equal to range and B is range. For F inverse, what will happen? For F inverse, B will be domain, B is going to be the domain and A is range. Now you know sin x always lies between 1 to minus 1 to 1, right? Correct. So range of sin x is minus 1 to 1. Now whatever is the range of sin x will be the domain of sin inverse x. So domain of sin inverse x will become minus 1 to 1 and range will become minus pi by 2 to pi by 2. Okay, right? Ulta will happen, minus pi by 2 to pi by 2. Okay, this much you need to, principal value branch or principal range. Now, two things you need to do for ITF. One is just see all the graphs, draw them on your own and remember the graphs. Although very less chances they might ask you the question on graph, but for your preparations and for the competitive preparations also I suggest that if you can do this, remember the graphs. Okay, this is, for example, you know the sin x graph, it goes like this. Sin x and cos x both are like this, just this will be shifted a little. This will be shifted by pi by 2. That's it. So if this is your y is equal to sin x, sin inverse x, what will be sin inverse x? Y is equal to sin x. So sin inverse of y will be equal to x. We can write like this. Sin inverse of y will be equal to x, or we can say y is equal to sin inverse x. If we are making this same graph is also of sin inverse y equal to x, but if we want to make a graph of y equal to sin inverse x, we just have to invert the x and y axis, nothing else. This entire graph will go on y axis if we are making y is equal to sin inverse x. If this is y equal to sin x, this will become y equal to sin inverse x, right? Check all these graphs are in your NCERT book only. Just same inversion only you are doing. You know all the graphs of cos x, tan x, you must know from 11th only. Sin, cos, tan, cosec, sec and cot. So just invert them. Take this same graph on y-axis. Nothing else. Right? If you remember the graphs of basic trigonometric function, then inverse trigonometric functions won't be a problem for you. Main thing over here, so you see all these are like these only. Cosec x is like this, and so which part will be taking? Now here also which part will be taking? We'll be taking this part from 0 to pi. Only in this one it is repeating, it's not repeating. Only in this one we can call it a bijective function. Otherwise it will keep on repeating. Only in this interval. So this will be principal value branch or principal range. This will be called as principal range. Okay, this much will be your principal range from pi to from 0 to pi. Okay, same for cosec, sec, tan and cot. Main thing over here is you remember this. If you remember this, your inverse trigonometric function question will be sorted. Only this table is important for your 12th boards exam right now. Right? You have to remember this if you want to get good marks in your 12th board. What is this? This is your domain and this is your range. Right? For sin x, range is -1 to 1. So for sin inverse x, it will become as domain. For sin x, domain is minus pi by 2 to pi by 2. So we are defining this. Range means this will become range because it will be a bijective function or it will be an invertible function only between minus pi by 2 to pi by 2. Right? How to remember this? For cos inverse and sin inverse, same domain will be there. For cosec inverse and sec inverse, same domain will be there. And for tan inverse and cot inverse, same range will be, so same domain will be there. Right? For range you see, range you'll have to remember. There is no direct like that. So for sin inverse, it is minus pi by 2 to pi by 2 and cos inverse is 0 to pi. You know, right? Sin inverse we define between minus pi by 2 to pi by 2, it does not repeat. Minus pi by 2 to pi by 2. In minus pi by 2 also, it will minus pi by 2 and pi by 2. In this much we have defined. And cos inverse will be defined as invertible between 0 to pi. Similarly, cosec except 0, everything 0 is not obtained, right? 0 is not. For cos 0 we don't define, right? Cos 0 we don't define because sin 0 is 0. So cos 0 is not defined. So 0 is in the range of, 0 is in the domain of, 0 is not in the domain of cosec x. So it will not be in the range of cosec inverse x. Similarly, pi by 2 is not in the domain of sec x. So it will be not in the range of sec inverse x. Same for tan inverse and cot inverse. Okay. So this table, importantly, you have to remember to solve the questions. Rest will be sorted. I'll show you how you can easily solve the questions. For example, this question. Okay. For example, this question. Now here what you need to do, you just need to find, main thing is, how will you find, how will you solve it? Sin inverse minus 1 by 2. Sin inverse minus 1 by 2. Let, first step you will write as let sin inverse minus 1 by 2 equal to theta. Then sin theta will be equal to 1 by 2. Right? Now, according to this, what is the range of sine inverse? Between minus pi by 2 to pi by 2. So, what will be the domain of this sine theta? Minus pi by 2 to pi by 2. Sine theta is negative. Sine theta is equal to negative 1 by 2. Now, sine is negative in second and third quadrant. Right? Sine is negative in second and third quadrant. Here, which quadrant are we talking about? Now, right, or you can write like this: principal value branch of sine inverse x, or principal range of sine inverse x is minus pi by 2 to pi by 2. So, which value will come between minus pi by 2 to pi by 2, where sine theta will be equal to minus 1 by 2? Tell me. Fourth quadrant. Right? Sine is negative in third. Sine is negative in third and fourth. Right? Sine is negative in third and fourth. But from minus pi by 2 to pi by 2, which quadrant is coming? Fourth quadrant is coming. So, you have to give the value of fourth quadrant. What will be the answer over here? Come on. Tell me. Sine is 1 by 2 for which value? Come on, tell me the answer. Just give me a minute. Sorry. Sine inverse 1 by 2 will be equal to pi by 6. Right? 30 degree. Come on, no answers. Sin theta can be minus pi by 2 for many values, but for which ones? For which value between minus pi by 2 to pi by 2 will be there, for which it will be negative 1 by 2? Tell me. Come on, solve. Obviously, minus pi by 6. Correct? Sine inverse of minus pi by 6. Oh, sorry, sine inverse of sine of minus pi by 6. Right? Negative value, so negative pi by 6. Either it will be on positive pi by 6 or negative pi by 6. So, here what will this become? Sine of pi by 3 minus pi by 6. So, this entire thing will become sine of pi by 3 plus pi by 6, which will be equal to sine pi by 2, which is equal to 1. This is how you are supposed to solve it. Only take the value which is coming between in the range. That's it. For example, this one or this type of question can be asked. Or let's do some a little bit of more easier side of questions. Let me give you so that you will be more comfortable. Okay, just simply find. Let's simply find sine inverse of minus 1 by 2. Suppose if I ask you simply sine inverse of minus 1 by 2. Just now we did actually. Right? Sine inverse of minus 1 by 2 will be how much? We know sine pi by 6 is 1 by 2. So, sine inverse of sine of minus pi by 6 it will be, just now we found, it will be minus pi by 6. Right? Between minus pi by 2 to pi by 2, which value will give you minus 1 by 2? Minus pi by 6 will give you minus 1 by 2. Okay. Find cosec inverse of 2, let's say. Find cosec inverse of 2. Find cosec inverse of 2. Tell me what will be the answer for cosec inverse of 2. Come on. For sine, sine 30 is 1 by 2. So cosec 30 will be 2, right? Cosec pi by 6. Cosec pi by 6. Principal value of cosec inverse is how much? What is the principal value of cosec inverse? This thing you have to remember. Minus pi by 2 to pi by 2 minus 0. So 0 to anyway, it's not coming between. So remember minus pi by 2 to pi by 2. So cosec inverse 2. When is cosec 2? So how will you do it? Let cosec inverse 2 is equal to theta. So your cosec theta will be equal to 2. Now for which theta? Between minus pi by 2 to pi by 2 except 0. For 0 it will not come, right? Except 0 will give you value 2. So answer is pi by 2. Or this same thing you can write like this also. Cosec inverse of cosec 2 is cosec pi by 6. So this way also directly you can give the answer. This will be cosec pi by 6. So simple ways, right? So just remember you have to give your answer between the principal value branch. Find one more. These from NCERT only I am giving you. Tan inverse of negative root 3. Let's say we want to find tan inverse of minus root 3. Again, we'll take tan theta equal to root 3. This will become tan theta equal to root 3. Sorry, negative root 3. Negative root 3. Now, when does tan give you negative root 3? Right, 60 degrees. Right, but the range is between minus pi by 2 to pi by 2. Right, and tan is negative. Where is tan negative? Second quadrant it is negative. Correct. Third quadrant also it is negative. Sorry, third quadrant it will be positive. Second and fourth quadrant it is negative. Correct. Now check between minus pi by 2 to pi by 2, which will give you negative root 3. Which value will give you negative root? Pi minus pi by 6. Right. Pi minus pi by 6. Pi minus pi by 6. Second quadrant will choose na. Minus pi by, between minus pi by 2 to pi by 2 if we are checking. For tan inverse ranges between minus pi by 2 to pi by 2. If you are checking minus pi by 2 to pi by 2, which quadrant will fall? Where it is negative. Which quadrant will fall? Where it is negative. Fourth quadrant. Correct. So it will be in the fourth quadrant, which value should come? Negative pi by 3. Right. Negative pi by 3 should come. So this will come out to be equal to negative pi by 3. 2 pi minus pi by 6 actually. So theta, so tan inverse negative root 3 will just come out to be equal to negative pi by 3. So these type of questions you can solve like this. One is this particular category of question, which also you should know how to solve. So here again, take tan inverse 2 equal to theta. So tan theta will be equal to 2. And here write like this, let cot inverse 3 equal to theta. So cot theta will be equal to 3. Okay. Now solve this. So sec inverse, sec square, this will become tan inverse 2, we have taken theta. So sec square theta plus cosec square, oh we have to take not theta, let's take this as phi. Okay, so cot phi will be equal to 3. Okay, cosec square phi. Okay, now sec square you can write in terms of tan. Correct. 1 plus tan square theta will become equal to sec square theta. So here you write 1 plus tan square theta plus cosec square theta. 1 plus cot square theta will be equal to cosec square theta. So 1 plus cot square theta we will write over here. So here it will become 1 plus tan square theta, that means 1 plus 4, and 1 plus cot square phi, that means 1 plus 9. So this value will become 13, 14, 15. This will become 15. That's how. This much only. For inverse trigonometric function, only first exercise you are supposed to solve. Just solve very carefully. One more question is there. Yeah. This question came last year only. This question came last year. 2024 question only is this, and this question came in choice. First part, you know how to solve. Okay. Just take the values in principal value branch. Okay. Chalo, I'll give you some time. Solve the first part and tell me the answer if you are here. Come on. Solve the first part and tell me the answer. Tan inverse minus 1 by root 3, cot inverse 1 by root 3 and tan inverse minus pi by 2. Come on. So minus 1 by root 3 will be tan minus pi by 6 between minus pi by 2 to pi by 2. Cot inverse root 3 will become cot pi by 3 and minus pi by 2 will be received at minus 1, right? Minus pi by 2, sine of minus pi by 2 will become just minus 1. Okay. So this one if we need to solve, this will be tan inverse of tan minus pi by 6, correct? Minus 1 by root 3 will be received at minus pi by 6 plus principal value branch of cot, right? Principal value branch of cot is what? Remember this table. Okay, principal value branch of between 0 to pi. Cot will be between 0 to pi. So you have to give your answer between 0 to pi, where cot is 1 by root 3. So at pi by 3 it will be. So we can write cot inverse cot pi by 3. We can write cot inverse cot pi by 3. You can solve like this. Okay. Plus tan inverse sine minus pi by 2. That means sine. That means minus 1. That means tan inverse minus 1. Correct. So this will become, what will this become? Minus pi by 6. This will become pi by 3 and tan inverse minus 1, that means pi by 4, minus pi by 4. Minus 1, that means plus minus pi by 4. That's it. This will be your answer. Just calculate this and this will be your answer. How much will this come? 4 3s. I think 12 will be the LCM. So pi by 12 or pi by 12 will come. I think pi by 12 should come. Minus pi by 12 should come. Okay. My main point is this question which came in choice. Find the domain of sine inverse x square minus 4. So find the domain of y is equal to sine inverse x square minus 4. What will be the domain? Domain means where will this lie? In y is equal to x. X is the domain, right? So domain of sine inverse x square minus 4. What is the domain of sine inverse theta or sine inverse x? Domain minus 1 to 1. That means this will lie between minus 1 to 1. That's it. Only this much you have to apply. Sorry, not this. Not this. Sine inverse x. Domain. What is the domain? Sine inverse x domain. Range is minus pi by 2 to pi by 2. Right? This will lie between minus pi by 2 to pi by 2. But x in sine inverse x, x will lie between 1 and minus 1. This is the domain. If this is equal to y, then y will lie between minus pi by 2 to pi by 2, but x can lie between minus 1 to 1. Because I showed you, right, according to the table, if I again go on the table, for sine inverse x, this is your domain. Domain means where x can lie. So that means in this question, what you had to do is, in this question, what you are supposed to do is that your x square minus 4 will lie between 1 and minus 1, and then you can solve. So minus 1 plus 4 will become x square will lie between minus 1 plus 4, so 3, and 1 plus 4, so 5. So x square will lie between, so x will lie between root 3 to root 5. That's it. So this will be your domain. What will be the domain? from root 3 to root 5. That's it. This much only you are supposed to do. Okay. Now do some more questions from NCERT, from inverse trigonometric question, inverse trigonometric function. It is a 3 mark you can obtain, easily 3 marks, only one table you have to remember and some values of sine, cos, tan which you are remembering from class 10th only. Okay, where it is positive, where it is negative, those things only you have to remember, but practice ITF also from NCERT and NCERT examiner. Okay, these all are the type of questions which you can expect from relation function and inverse trigonometric function. One more type which is remaining, which is case study of inverse trigonometric function, which we will do on the 5th day, where we will be doing case studies separately. Okay, so this much is the type of question. Revise this lecture. After this, practice from NCERT also how to write the answer, everything. I'll keep coming up with more suggestive videos, and tomorrow we'll be doing matrices and determinants, the algebra part. Okay, so attend the session tomorrow also, and that's it then. All right. Okay, take care. Thank you. Bye bye. Have fun. Don't forget to hit on the notify me button. Do like the session if you liked it, and subscribe the channel. Thanks a lot.